All right. Hello, world. Can everyone hear me okay? Testing 1, 2, 3. All right. Well, so nice to see everyone again, whether it's morning, evening, or afternoon where you are. My name is David Malan. This is going to be our live shoot of CS50P's lectures 3 and 4, the goal of which then is to cover two broad topics today. We'll take a break in between the two of them. So even though at the end of the first lecture you hear me say goodbye, we'll take a break and then resume. Of course, you can tune out or go to sleep at any point you would like. Before we begin, especially if you are new here, know that you can go to this URL here if you want to get copies of any of today's slides or the source code that we are going to be writing. And allow me to make this suggestion. We found it to be a net positive to leave Zoom's chat enabled, even though it can get a little annoying with all of the pop-ups, especially with so many people here. So if you're unfamiliar with this, you can find next to your chat window in Zoom on desktop, not on a mobile device, you can go to the little triangle at the top left-hand corner of the chat window and choose pop out, and that's going to pop out a window. The language might be different if you're not using English. And then what you can do very hackishly is drag and drop it to like the bottom corner of your screen so that it doesn't keep alerting you with all of the pop-ups. Andrew, I'm seeing my third monitor over here is me instead of gallery mode. Do we need to rewire something, reroute? Sorry, I'll just chatting with the team here. And back right monitor is off. Can I forge ahead with conversation while we fix this? Yeah, no problem. OK, so we're going to make a few fixes here. And then lastly, if you would like to follow along with what we're doing here hands-on today, you can go to this URL here, which is CS50's own adaptation of a tool called Code Spaces, which will allow you to use a product called VS Code, Visual Studio Code, for free in the cloud. You can alternatively download and install VS Code on your own Mac or PC, but there tend to be some technical support headaches sometimes. So we would encourage you both today and beyond in this class, if you want to play along, use this URL here. However, with that said, today, if you've been here before, we'll go pretty quickly and we'll move from example to example. And so don't feel you need to follow along live. The whole point is to introduce topics today and then in the course's problem sets or programming homework to actually apply these lessons learned. So not to worry if you find it's a little too fast and you can't keep up. That's not the goal. The goal is really to introduce you to some of the ideas today. Why don't we go ahead and take a few hellos and photos after our traditional souvenir photo here. So if you'd like to participate in this, make sure your camera is on. If you would like to opt out of appearing on the internet in this photo, turn your camera off. And in just a moment, I see a few of you are super eager already. That's great. Go ahead and wave and put on your best smile. If you'd like to appear in this souvenir photo, I'm going to put up a more flattering slide here. For my own here. Here we go. So if you want to go ahead and keep waving and smiling for a moment here, my colleague Rang Xin here in the lecture hall is paging through all of the Zoom tiles, screenshotting and screenshotting and screenshotting. And he's going to run some fancy software ultimately to stitch them all together into one big gallery as though we're all in one big room. And I'm still stalling. He's still screenshotting, still waving. Tragically, we only need you waiting for like a second. We just don't know which second we need. OK, and we are now done. Give us just a moment. Andrew, do you think we're going to be able to rewire this? OK, just rerouting some signals here. Why don't we take a moment to take like 2 or 3 hellos? If you'd like to first say hello in the chat window, feel free to say hi and where you are in the world. And then maybe via a volunteer. Could we call on someone to say hello on camera as well? Let's see. We have a few hands up. How about we go to Zegum, if I'm saying that right?
Hello, I am Jagam. I am from Pakistan, and I am very grateful and happy to be here and learning a lot.
Nice. Well, welcome to the class. Glad to have you. How about another group hand from the group? Maria?
Hi, this is Valerie. I am from Toronto.
Oh, Valerie from Toronto. Oh, so are you might be using Maria's Zoom then, I see.
Yeah, I'm very happy to be a part of this free programming Python class with you. And yeah, I look forward to learning more about programming.
Wonderful. Well, glad to have you aboard as well. And let's see, Amaka, if I'm saying that right. Welcome to the class.
Hi, my name is Amaka from Nigeria. This is really very interesting class. I'm so happy to be part of this class. Thank you.
Oh, likewise. Welcome and nice to meet. Let me see if we're almost ready here. We're just adjusting some of our monitor. Close. We're getting close, so time for some more hellos. For those unfamiliar, I have all of these big monitors in front of me. So if you see me looking over here, over here, over there, I'm looking at you on just these various screens. Rungshin, could we spotlight someone else, unless your attention is split? How about we go over to, let's see, Piyush, if I'm saying it right? There we go.
Hello. Hi. Thank you for having me. I'm Piyush. I'm from the UK. I already am at a computer science course in one of the universities up here, but I'm taking this course to broaden my knowledge. And Python's pretty new for me, and it's very good. So, yeah, thank you for having me.
Wonderful. Well, welcome to you as well. And I think we're just about set here. We're just fixing some wires. Just to test Rungshin, can we go back into gallery mode for everyone? Middle monitor too? And I hope you'll forgive. So many hands up, but so much Python to learn. Let me just make sure we're working, though, correctly. I still see Piyush pinned on middle. OK, now we're good. OK. Good, good, good. Yes, now we're good. Again, let me give the team here a moment. Just about set. Yeah, we're just pinning the 1 this time, too. Yes, Rungshin? OK. We're just pinning me. For them, we're just pinning me today. Spotlighting me. I thought we didn't want to spotlight the laptop anymore because it's redundant. Oh, I see. OK, gotcha, gotcha. But they can resize anyway, right? OK, gotcha. OK. How about one more hello? I know there's so many hands up, but let's do one more hello before we learn some Python. Who do we have lastly here? All right, and we have Melvin, if you'd like to say hello.
Hello, I'm Melvin Bayusan from the Philippines, and it's currently 12 a.m. here. I'm so happy to attend this class.
Likewise. Well, nice to have you aboard, too. And we're going to go ahead and put down the hands, if that's OK. We're going to give ourselves just a moment to reset here. The overarching topics today, as you'll soon see, are going to be exceptions first and handling errors, followed by a break, followed by ultimately a look at libraries and actually using third-party and first-party libraries in Python to solve all the more problems with your and other people's code. All right, give us just a moment here to reset, and we'll begin. Andrew, do you need to pop out again?
I think we're all set in here.
OK.
The audio's still up.
All right. And so we can start when you are, whenever I'm ready?
Yep, we're all set.
OK, cool. OK. Still pinned on the middle, Rungshin? OK, we're good now. Yeah. All right, this is CS50's Introduction to Programming with Python. My name is David Malan, and this is our week on exceptions. Exceptions in Python, as well as in other programming languages, refer to problems in your code. Indeed, when something is exceptional in your program, it actually doesn't mean it's a good thing. It means something has gone wrong that ideally you will somehow solve. So what are some of the things that can go wrong? Well, let me propose that we go over here and pull up VS Code and start writing a program. Something very simple like, again, hello world. So I'm going to go ahead in my terminal window and run code of hello.py in order to create a new tab running. Ah, damn it. Sorry, Andrew. The file already existed. Do you want me to start that from the top or do it from here?
You can just have me walk into that chat.
OK. All right, this is the movie magic part. Pretend everything just happened, and here we go. So I'm going to go ahead and open up VS Code on my computer here. And in the terminal window, I'm going to go ahead and run code of hello.py. That's going to, of course, open up a brand new tab for me, hello.py, in which I can write my code. And let me go ahead and write some very simple code just to say hello to the world. Let's go ahead and say print, quote, hello, comma, world. And then let me go ahead and I'm forgetting to close that quote. So a mistake that you yourself might have already made or might surely in the future make. And it's a little subtle because you might not necessarily notice that you've just missed that one character. Well, let me go ahead and somewhat optimistically go down to my terminal window now and run python of hello.py and hit enter. And that's the first of my errors. My gosh, I've only written one line of code, and I seem to have more lines of errors on the screen. But the salient point is this bottommost thing here. Notice where it says syntax error. A syntax error is a problem with the code that you have typed, your syntax. Just like English and other human languages have syntax associated with them, so does my code. And it's not quite correct. Something is awry. I didn't follow the instructions properly. And it does elaborate for me. Unterminated string literal. Now that's a bit arcane. That is a bit of a confusing error message, but unterminated would generally mean that I started something but didn't stop it. I didn't terminate it. String, of course, is a sequence of text like we discussed before, or str in Python. And literal generally refers to something that you literally typed. It's not a variable. It's something like quote unquote, or just quote, hello world. So the fix here, of course, is going to be to go ahead and terminate that string and actually close the quote. And if I now go back down into my terminal window and rerun python of hello.py, now I'm saying hello to the world. So the catch with syntax errors here is that syntax errors are entirely on you to solve. A syntax error is a problem that you've got to go back into your code and fix from the get-go. You can't just kind of hope that it's going to resolve itself or expect that other parts of your code will catch it for you. Syntax errors just must be fixed. But there's a lot of other types of errors in Python that might be described as runtime errors that happen while your code is running. And it's really up to you to write some additional code defensively to detect when those errors happen, because you don't necessarily know, for instance, what input humans are going to type into your program. And so you better be ready defensively to accommodate things that they type or even mistype. So for instance, let's go back over here to VS Code, and let me propose that we take a look at a new file altogether. I'm going to close hello.py, and I'm going to write code of, say, number.py. So let's play around with some numbers in Python. And the first thing I'm going to go ahead here and do with number.py after opening this new tab is I think I'm going to go ahead and type up a relatively simple program that maybe prompts the user for an integer like x and then just prints out what x is. So we're going to start super simple. But again, in starting simple, we'll be able to really see where I've done something wrong. Well, here we go. I'm going to go ahead and say a variable called x is going to get assigned the value of the return value of input, quote unquote, what's x question mark. And I'm going to include a space to move the cursor over a little bit. And then ultimately, I'm going to go ahead and, oh, wait a minute, if I'm wanting to get an int from the user, recall that I need to do something proactively. I need to actually convert that input to an integer using the int function in Python. So now I'm passing the return value of input as the argument to int, and that will store in x ultimately an integer, not a string that looks like an integer. All right, let me go ahead now and just quite simply print out what this is. I'm going to go ahead and print out, quote unquote, x is x. But I don't want to literally say x is x. I want to plug in the value of x. So maybe the easiest way to do that is to surround it with curly braces. And then if I'm using these curly braces and I want Python to interpolate the value of that variable, that is, substitute what x actually is in between those curly braces, recall that I need to use a format string or an f string by prefixing this whole thing with an f. Now that I've done that, let's go ahead and see what happens. I'm going to go ahead in my terminal window and run python of number.py. I hit enter, and so far so good. All is well. I'm being prompted for x. Let me go ahead and type in a number like 50. All right, that seems to work. Program seems to be correct. Or is it? What could go wrong in this program, even though nothing did just go wrong? But if I run it and run it and run it again, during the running of my program, what could still go wrong, especially if I'm not the human interacting with it, but some other human instead? Any volunteers here for this one? What could go wrong? And in what way is this program not really correct, even though at first glance it seems so? How about, let's see, Shashank, if I'm saying it right?
Yes, sir, I have a doubt. I have a doubt, sir.
Sorry, you were a little quiet. Can you say again?
I have a doubt, sir. I have a doubt.
Say again. I'm sorry, having trouble hearing you.
Yeah. What is an interpreter? So, when we code in a integrated IDE, we can't code in an interpreter.
So I'm not calling an integer. I'm still having trouble hearing you, but what I think I heard is that if what the user types in is not in fact an integer, I can't just blindly convert it to an int. If I'm not putting too many words into your mouth, I think what I should perhaps do here is be a little defensive and let me see if I can't simulate exactly the problem that could go wrong here. Let me go ahead and run, again, Python of number.py. Let me try another number. In fact, when testing your code, generally it's a good idea to test corner cases, maybe numbers that aren't quite as plain as 50 or 49 or 51. Let's choose some numbers that might be a little more interesting, if only mathematically, like 0. All right, 0 seems to work. My code still prints out that x is 0. What might be another corner case to consider? Well, let me go ahead and try a negative number. That, too, is pretty different in spirit from 50. -1. OK, that works, too. Well, let me try it one more time. I've tried positive numbers, negative numbers, 0. Let me try something like a cat. So literally, C-A-T, typing in a string that doesn't even look like a number. And yet, let's see now what happens when I hit enter. All right. We'll see now we've got another kind of error. It's not a syntax error because I didn't make a typographical mistake. I didn't forget some piece of syntax. I actually now have an error with one of my values. And it's in a value I didn't even anticipate. The human, me in this case, typed it in long after I wrote the code. So what does this refer to? A value error. Well, let's see what the explanation is. Invalid literal for int with base 10, quote unquote, cat. Now, this too is a bit of a mouthful. And unfortunately, in Python and a lot of programming languages, the error messages are written for pretty comfortable programmers. And of course, when you're learning programming for the first time, you might not be so comfortable with the programming language, let alone the error messages. But let's see if we can't glean some insight. So invalid literal. Well, again, a literal is just something that's been typed in, it would seem. For int, what is int exactly? Well, int is the function I'm using to convert the user's input to a corresponding integer. Base 10, that refers to the decimal system, which is the default that Python's using. And it looks like, at the end of the day, what Python really doesn't like is that I passed cat, quote unquote, to the int function. So how do I go about actually fixing this problem? Well, I could just add instructions in my program. Maybe I could add a line of print telling the user more explicitly, be sure to type an integer. Or please don't type cat. Please don't type strings. Of course, the user might still not oblige. They might not be reading the instructions. So that, too, is probably not an effective strategy. What we really want to do is write our code with error handling in mind. We want to write lines of code that not only accomplish the problems we care about, but that also handle errors that might unexpectedly happen. And in general, when programming defensively, assume that the users aren't going to be paying attention, or worse, they're malicious. They're trying to crash your program, so we want to handle as many errors as we can. Now, how do we go about doing that in Python? Well, it turns out whether you want to catch a value error or other types of errors as well, though not syntax error, Python actually has this keyword called try. And it's sort of aptly named. If you want to try to do something in Python, you can literally use this keyword, and you can check whether or not something exceptional, something erroneous has happened. So using both try and this other keyword except, can I go and try to do something, except if something goes wrong, I can do something else instead. So let's consider, how can I go about trying to convert the user's input to an int, except if something goes wrong? Well, let me go back to my code here. And let me propose that I now modify this example as follows. Let me go ahead and above my first line of code, I literally write try and a colon, telling Python, try to do the following. I'm going to go ahead and indent my existing lines of codes here by the same number of spaces, 4 in this case. And then I'm going to add one more new line down here that literally says except value error. And notice it's important that I've capitalized the V and I've capitalized the E. These symbols are case sensitive. And this is now an opportunity, after this colon, to tell Python what I want to do in exceptional cases, when the number or the input from the user is not, in fact, a number. And I'm going to say something plain like print, quote unquote, x is not an integer. I'm at least going to tell the user roughly what the problem actually is. So notice another detail. The indentation is important. Because I have try on line 1 and I've indented lines 2 and 3, those are the 2 lines of code that I'm trying. Except if I see a value error, line 5, because it's indented, is what is going to get executed in cases of those errors. Let me go ahead now back to my terminal window and run Python of number.py, enter, and let's go ahead and type in 50 again. Still seems to work. And of course, I'm trying and succeeding. Let me go ahead and try once more. This is really anything that's not a decimal number. And now you'll see much more cleanly x is not an integer. I'm not seeing some scary error message that I, as a user, am going to have no idea how to handle. Now you, the programmer, have anticipated that something exceptional can happen, and you've gone about actually handling the error for the user, giving them an appropriate error message instead. Let me pause here and see, are there any questions now on what we've just done by introducing try and except to handle this value error? Yeah, Dev, question.
Is value error the only type of error you can get, or are there other types?
Is value error the only thing you can catch? There are other errors as well, and we'll see a few of them today. And there's many, many more, honestly, that if you continue programming in Python, you're going to see a lot of them over the weeks, the months, the years to come. But the technique for handling them is going to be largely the same. Other questions on try, except, or these exceptions more generally? Yusuf?
Yes. Sir, actually, to use the except block, you need to know the type of error, right? Like here, you knew it was a value error. What if you can't anticipate this particular type of the error?
A really good question. So I'm being very good about catching, so to speak, the very error that I know might happen. I don't know when it might happen, because it's going to depend on the user, but I know what kind of error will happen from the int function. There is a way in Python where you can say except if anything goes wrong, and you can literally omit value error and just catch everything. The problem with that is that it sometimes hides other bugs in your code because you don't necessarily know what's going wrong. And if you don't necessarily know what's going wrong, how can you possibly handle it correctly? So bad practice. And put another way, it's lazy to do that, to just say catch everything and I'll deal with it here. So a much better practice would be to figure out what kind of errors could happen and include mention of them explicitly as I've done. Now, with that said, if you read Python's official documentation, as you'll eventually invariably do, it is not great about telling you proactively what kinds of errors can be raised in this way. So it's a bit of contradictory advice. You should do it this way, but it's not always obvious what you should be checking for. But you get better at it with practice. And some of the times the documentation does spell out what could go wrong. Let me turn our attention now back to this and point out that even though this is better code, it is more correct in the sense that I'm not just leaving it to the user to see some really ugly default Python error message that most people are going to have no idea what to do with. I'm at least handling it more elegantly, and I'm printing out x is not an integer. So it's at least more instructive. But this isn't necessarily the best way to implement this code. Why? Well, here too, I'm actually still being a little lazy. So notice that I'm trying to do not one line of code, but 2 lines of code. And this isn't a huge deal because we're only talking about 2 lines of code. But in the interest of preaching best practices, you should really only be trying to do the one or very few lines of code that can actually raise an exception, that can actually fail in some way. I am pretty sure that calling print here is not going to raise a value error. Whether x is an int or a string or a float or anything else, the format string feature of Python is going to handle printing it just fine. So really, what I'm going to do is this. I'm going to move this line 3 down to the bottom of my code. I no longer need to indent it. I'm just going to execute it at the bottom of my file here. Unfortunately, by doing this, I've done a good thing by now only trying to do the minimal amount of work necessary that might raise the exception, a value error. But I fear I've introduced a new mistake. Well, let's see. What is now incorrect? Let me go ahead and again run Python of number.py, enter. Let me go ahead and do it correctly with 50. And all seems to be well. But again, let's try those corner cases, the zeros, the negative numbers, or in this case, the cat. Let me go ahead and type in CAT again, enter. Now I have a name error. So now it's yet another type of error in my code that I've introduced here. And what does this name error mean? Well, just as a value error refers to that, the value of some variable, the value that someone has typed in is incorrect, name error tends to refer to your code. Like you're doing something with the name of a variable that you shouldn't. And why might that be? Well, let me turn our attention back to the code here and consider, what is it complaining about? Well, the name error is what I see down here. And it's telling me name, quote unquote, x is not defined. And notice if I look further here, it is mentioning line 6. So I know the problem is with my code on line 6. And that worked a moment ago. And I'm defining x on line 2. But let me ask the group here, why does x not, in fact, exist on line 6? Why is it not defined, even though I'm pretty sure I was intending to define it on line 2? What's the explanation for this error? Alan, if I'm saying it right?
Yes, thank you. I think that indentation is the cause of error.
A good instinct, but not
because we.
Oh, go ahead.
Yeah, because we are defining x in line 2 in indentation in the try function, sort of speaking. Try statement. But print is out of indentation.
So really good instinct and a correct answer in other languages like C and C++ and Java. It turns out in Python, no matter where you define a variable inside of a file like this, whether it's indented or not, it's going to exist everywhere else thereafter after the line of code executes. That's not true in certain other languages. So a good instinct, but let's push a little harder here on why this still might be erring. Someone else? Why this error? Divya?
Maybe the scope of the variable is between the try block.
So good terminology. Scope refers to the portion of code in which a variable exists. That too, though, isn't quite right in Python. That would be true in C, C++, and Java, where indentation or curly braces tend to define the scope of a variable. But again, here in general, and this worked a moment ago, x exists once it's defined on line 2, because remember, I printed out x is 50 a little bit ago. Let's try one more hypothesis here. One more hand. Why is x somehow still not defined? Gavelin, if I'm saying it right?
Yeah, so is it because it's local variable, meaning that like it doesn't define outside of the scope? Because like what people have mentioned, it prompts the input in try, right? But outside of it, it's undefined.
So still good instincts and good terminology too. There's this notion of local variables, which tend to exist inside of functions, for instance. Global variables, which tend to exist in entire files. In this case too, though, that's not quite the case. What's happening here boils down to order of operations. Let me come back to the code here and recall that anytime we've discussed the assignment operator, the single equal sign, that copies a value from the right to the left. But consider for a moment at what point something is going wrong. Well, the input function is probably working just fine, because we've used that a lot now to get users' input. It always returns a string or a str in Python. But what could be going wrong? Well, if I'm passing that string to the int function as its argument, it's probably the int function that's erring. And indeed, if you think back earlier when we had the value error, it was in fact the int function that did not like quote unquote cat as input. So this is all to say that this portion of my code, highlighted now to the right of the equal sign, that's the code that's creating a problem. That's the code that was creating a value error. And in this case, we're catching the value error. But because the value error is happening on the right of the equal sign, there's no value being copied to the left. The error is interrupting that whole process. So even though we see x equals ... on line 2, the portion of that line to the left of the equal sign isn't getting evaluated ultimately because the value error is happening too soon. And so when we finally get down to line 6, even though it looked like I was defining on line 2, and I would have defined x on line 2 if all had gone well, we didn't get to the part where the value is copied from right to left because the value error happened first. So this code is just incorrect now. So how do I go about solving something like this? Well, it turns out that there's another feature of the try and except syntax that Python supports, which is that it also supports the keyword else. Now, we've seen else before. If you think back to our discussion of conditionals, we saw if, we saw elif, we saw else, which was kind of this catch-all, what you should do in the event that nothing else is relevant. That's kind of the same intuition here for the try except feature of Python. What you can do is this. You can try to do the following, as I've done, except if this goes wrong. But if nothing goes wrong, else go ahead and do this. So this is one way I can solve this same problem now. No matter what now, Python is going to try to execute line 2. If something goes wrong, it's going to execute lines 3 and 4 to handle that value error. However, if you try and this code succeeds, then there is no exception to handle, so you're then going to execute this line here. So it's a little confusing perhaps in that we're now using else both for conditionals, if, elif, 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 else, and we're also using else with these try except blocks, but that's okay. That's part of the language. That's one of the features. So now if I rerun this code in my terminal window, Python of number.py, let's do something correct like 50, I see that x is 50. So line 1 is executed. We're trying to do the following. Line 2 is executed because the conversion happened successfully and the number 50 gets copied from right to left. The exception does not happen. So we ignore lines 3 and 4. We jump immediately to line 5 and 6, which prints out the result. By contrast, though, let's do this one last time. Python of number.py, let's type in cat or, again, any other word and hit enter now. We don't see what x is. Rather, we see, quote unquote, x is not an integer, which is what's being handled in my except clause. All right, let me pause here, because that's a lot of new syntax, and see here if there's any questions on try, on except, on else, name error, or value error. Yeah, let's see. Daniel?
Oops.
Yes, we can hear you. Daniel?
Oh, sorry. I raised up the hand before.
Oh, the before? OK, we'll call on someone else. Not a problem. Questions on try, except, else, name errors, value errors. How about over to? Yeah, Rohit?
Hello?
Yes, we can hear you.
Can you hear me?
Yes.
Can you please repeat try function?
Can I please repeat what?
Number error. Oh, name error.
Did you?
Hello?
Say again? The name error?
Name error.
Yes, sorry, I'm just having trouble hearing you down here, but my colleague is filling me in. Repeat the name error. What's the problem with the name error? Yeah, so let's just rewind a couple of lines here before I fix this problem by now getting rid of the else. A moment ago, we had code that looked like this, whereby I was getting a name error, Python of number.py, enter, typing in cat, that looked like this, where name x is not defined, and the problem was on line 6, according to this output in Python. Well, let's think about this now deductively. Let's try a different approach. On line 6, I'm seeing an error that name x is not defined. OK, Python's already telling me x does not exist at that point. So how could that possibly be? Well, where should x be defined? Well, presumably x is defined on line 2 up here. So what could go wrong? Well, if the user has inputted something that doesn't look like a number, like the word cat, passing cat, the return value of input, as the argument to int to convert the word to an int makes no sense. You can't convert a cat, C-A-T, to an integer at all. So the int function is raising a value error at that point, and the error is being handled with this code here. But notice, this line 6 is not indented. It's left aligned with the rest of my code, which means no matter what, line 6 is going to execute. It's going to execute whether I typed in 50 or I typed in cat. But if I typed in cat, again, x never gets a value, so it's not defined here on line 6. So when I introduced finally the else statement, that makes sure that these things are mutually exclusive. I only execute the else if I tried and succeeded up above. Well, let me propose that we refine this just a little bit further as well and consider how we might improve this example a little bit more. It's a little unfriendly of me to be rejecting the user's input after they fail to provide an integer and just quitting the program really, right? It'd be more user-friendly if I just prompt or reprompt the user again and again. And in the chat, if you could, what's the feature of Python that you can use if you want to do something again and again and again until such time as the user cooperates and gives you what you're looking for, like a number? So yeah, loop, loop, loop. So a loop is something that happens again and again and again. And maybe we can use that same mechanism, a loop, in order to prompt the user for x. And if they don't give us a number, prompt them again. And if they don't, prompt them again and again and again. We don't need to just quit out of the program so quickly. So let me propose this. Let me propose here that I improve this code by deliberately doing this. Let me induce a infinite loop at the very top of my code with while true. Recall that the while keyword induces a loop, a cycle that behaves like this, and it asks a question, a Boolean expression that needs to evaluate either to true or false. Well, if I want this thing to loop forever, at least initially, we'll just say while true, because true is true, so this has the effect of doing something no matter what forever, unless we break out of it early. Now I'm going to go ahead and do this. I'm going to go ahead and move my try except code indented underneath this loop so that I'm trying to get an x. If I have a value error instead, I print out x is not an integer. But this time, what do I want to do if the user does try and succeed in giving me a number? Well, I can do this. I can just break out of my code here. And down here now, I can use that same line of code from before, an f string that says x is, and then in curly braces, x again. So what's going on here? I think this code now, because I've added the loop, is going to have the effect of trying at least once, maybe a second time, maybe a third time, maybe 500 times until the user finally gives me what I want, which is an integer. And once they do, once there's no value error happening, then I break out of the loop and line 9 executes as I would hope. So let me go ahead and try executing this version. Python of number.py, enter. What's x? Let me go ahead and type in the easy thing first, 50. X is 50. What just happened in terms of the control flow of this program, the flow of my logic? Well, I first found myself on line 1 inside of a loop. Hopefully, I'll get out of this loop. What did I then do? On lines 2 and 3, I tried to get input from the user and convert it to an int. Well, I was a nice guy this time, and I typed in 50, which looks like and is a number. So the int function converted it just fine and stored it from right to left in x. Except value error, there is no value error, because if I typed in a number, there's nothing exceptional happening. This is a boring, good execution of my program. So what happens? I break out of the loop. So again, the else clause is associated with the try, not with the except. And once I'm out of the loop, of course, I'm just printing out what x is. Well, let's try the other scenario that might happen. Python of number.py, enter. What's x? Let's try cat, or any other word. Enter. This is now a new feature. I'm being informed what I did wrong. X is not an integer, so I'm getting some useful user feedback. But notice again I'm prompted, what's x? Well, let me try typing in dog. X is not an integer. What's x? Let me try bird. Enter. X is not an integer. What's x? And suffice it to say, this will happen now forever if I'm in an infinite loop until I try and succeed, at which point I break out. So let's try again. 50, enter. Now I'm out of the loop, and I'm printing out what x actually is. All right, let me pause here and see if there are any questions. The logic is almost the same, but what is different now is I'm in a loop, and I'm using the keyword break in Python to deliberately break out of the loop when I'm ready to, once the user has cooperated. Let's see, question from, Yorgo, if I'm saying it right?
Hi, thank you so much.
Sure.
Do we really need to break? Can't we just print? Or what keeps us from just printing?
Good question. So let me try that. Couldn't I just print? Well, let's see what happens if I do that. Let me move this print line at the end into my loop here, thereby shortening the program. And in general, that's been a good thing. Python of number.py, enter. Let me go ahead and type in 50. OK, x is 50. What's x? OK, maybe it's 49. X is 49. OK, maybe 48. Unfortunately, I think you're laughing. You see it. I never break out of the loop, which maybe that's a feature. Maybe you want this to be your program, but I didn't. I'd eventually like this game to stop. So I need to break out in that way. But I can do it a little differently. And let me propose that we modify this a little bit. But first, any other questions on this syntax here? Let me rewind to the prior version. Yeah, a question from Cecilia, if I'm saying it right.
Hi. Can I use break or in exception except in else? For example, in another print, when you use print in the else, you can use print together with break or something like this?
So you can use break inside of loop, and you can use it inside of a conditional, like an if, an elif, or an else. You can do it inside of a try, except, else statement too. Anytime you're in a loop that you want to break out of, you can use this keyword break. I'm using it in the context of exceptions, but it's not restricted to that. And let me show you too, it doesn't even have to be in the else. If I wanted to, I could actually do this. I could get rid of my else, and I could go back to line 3, add another line that's indented, line 4, and break out here. Now, why is this logically OK? Well, consider what I'm now trying to do. I'm trying to execute line 3 and converting the user's input to an int, and I'm trying to store the result from right to left in x. If something goes wrong, the code we've already seen is immediately going to jump to line 5 and then 6 to handle the exception. But if nothing goes wrong, my code presumably should just keep on executing line by line. So I could technically, logically put the break here and watch what happens when I run this version. Python of number.py 50 enter. It worked. I broke out of the loop. Now, which way is better? Honestly, I think it could go either way at this point. This program's so relatively short that even though I'm trying to do two things now, one of which, the break, is not going to fail. Like you either break or you don't. There's no piece of data from the user that's going to influence that. We don't strictly need to have those 2 lines of code there, but it's only 2 lines, so I think it's OK. And if you recall our discussion in the past, not just of correctness, does the code work as it should, but design, I think you could argue it either way. If you prefer the readability of this and the fact that you don't have an else, that's fine. If, though, you prefer to minimize just how many lines of code you're trying to execute in case something goes wrong, the else is a reasonable approach too. Well, allow me to propose too now that we refine this further. I think we're at the point where it's pretty darn correct. But suppose now that I find myself today and tomorrow trying to get numbers from the user quite a bit. It would be nice, as we've seen, to maybe just invent my own function, getInt, to get an integer from the user both today and tomorrow and beyond. And heck, maybe I can even share that function with other people if they want to write programs that get integers from users. So how might I go about doing this? Well, let me go ahead and propose that we do this. Let me get rid of the print line, but keep most of my loop here. Let me define a function called getInt that takes no arguments for now. And I'm going to go ahead and indent all of the code I already wrote underneath getInt. So now I have a function called getInt that tries to do the following. Try to get an int from the user. If something goes wrong and there's a value error, yell at them with x is not an integer. Else, break. But it's not just breaking that I want to do here. Now that I'm in a function, recall our discussion of return values. If you're inventing your own function whose purpose in life isn't just to print something on the screen like a side effect, but is to hand back a value, to hand you back a value, like on that same post-it note from our discussion of functions, well, you need to return x explicitly. How do I now use this function? Well, as soon as we start making our own functions, it tends to be convenient to define our own main function as well. That's the main part of our program. And I'm going to keep this simple. I'm now going to say x equals getInt. And then on the next line, I'm going to do that print from before, quote unquote, x is, in curly braces, x. And at the very bottom of my program, recall, I'm going to call main so that no matter what, I'm invoking my main function after everything's been defined. Well, let's see how this works. Let me go ahead and run Python of number.py, enter. Let's type in 50, and it seems to work as before. Let's go ahead and run it again, typing in cat, C-A-T this time. X is not an integer, and I'm being prompted. Dog, and I'm being prompted. Bird, and I'm being prompted. Fine, 50. That's an int, and so it is printed. So what's worth noting here, well, I'm manifesting a couple of good properties here. One, I've kind of abstracted away this notion of getting an integer. And even though I just artificially hit enter a whole bunch of times just to hide that function for now, it needs to be there, but we don't need to see it at this point. Notice that now this entire program really boils down to just these 3 lines of code now. Why? Because I've abstracted away that whole process of getting an int from the user into this new function of my own called getInt. But can I improve upon this? Well, let me go ahead and undo all of those blank lines and pull this up just so we can see more on the screen at once. Can I tighten up my implementation of getInt? It is correct. I claim this is correct. It's handling errors and it's returning x, but I don't, strictly speaking, need to write the code as long. What else could I do? Well, let me propose that if all you're doing on this line 13 is breaking, and then immediately after that, per the indentation, you're executing return x on line 14, why are you wasting everyone's time? Once you know you're ready to return the value, you could just return x. And so in my else, I could break out and return a value. So here too, return is used to return values from functions. Break is used to break out of loops. But it turns out that return is sort of stronger than break. It will not only break you out of a loop, it will also return a value for you. So it's doing 2 things for once, if you will. But can I make this even more compact? If my goal is to just tighten the code up, even though it's already correct, can anyone think of a further refinement, whether you've programmed in Python before or not? Can I shorten this implementation further, just a little bit, if only to decrease the probability that I've made a mistake by having fewer lines, and just make it a little easier to read because it's shorter? Any suggestions for tightening up my implementation of getInt? Yeah, Pratham, if I'm saying that right, your suggestions? Oh, still muted though. Still muted. Try once more.
You can just return the value on the try function when you're trying.
Yeah,
you take the input x and then return x.
Good. We can just return x a little higher up. And let me correct folks as we go. It's not a try function. It would be a try statement, technically. A function typically has a parenthesis and another one. In this case, it's just a statement. But we can do exactly that. I don't technically need the else. If I really want, I could do this. Right after line 9, I could return x here. Or recall our discussion of defining variables unnecessarily sometimes. Like, why define a variable here if you're immediately going to use it here and then never again? So we could avoid a new line here. And I could avoid even defining x explicitly. I could just say something like this. I could return int input, quote unquote, what's x. I can do it all at once. Now, which is better? I don't know. I mean, again, this is where reasonable people might disagree. I'd argue that on the one hand, we're tightening up the code. We're using fewer lines. It's easier to read, lower probability that I've made a mistake. On the other hand, it's a little more complicated to understand, perhaps. It's a little less obvious where I'm returning from. So I think arguments can be made either way. At the end of the day, what's important is that you've done this consciously. You've made a decision to do it this way or this way, and you can justify it in your mind, not that your answer is, it worked, so I left it alone. Like, have a good reason. Come up with a good reason, and that will come with experience and practice. Well, let me propose, too, that we make one other refinement here. Suppose that you're finding your programs to be a little noisy, and it's a little obnoxious that you keep telling the user x is not an integer, x is not an integer, x is not an integer. What if you want to make things a little gentler and just prompt the user again with the same words, what's x, what is x, what's x, again and again? Well, you can do that as well. And it turns out that if you want to handle an exception in Python, but you want to pass on doing anything with it, so you want to catch it, but you essentially want to ignore it. You don't want to print anything. You don't want to quit the program. You just want to silently ignore it, like if you're talking in a room full of people and it's your turn to talk and you're just like, pass. They're still calling on you, but you're not doing or saying anything more. Well, we can add this keyword to our code here. Let me go back to my program here. And instead of printing out again and again, x is not an integer, I could just do this. I could pass on handling the error further. I'm still catching it. So the user is not going to see a scary message even mentioning value error. My code is catching it, but I'm passing on saying anything about it. I'm going to stay in the loop. I'm going to stay in the loop and keep prompting and reprompting the user. So now the effect looks a little something like this. Python of number.py. Let's type in cat. What's X again? Let's type in dog. What's X again? Type in bird. So it's just a little, maybe more user-friendly in that you're just reminding the user what you want. Maybe it's worse. Maybe it would be helpful to tell the user why you're prompting them again and again. It's not obvious, so it could go both ways. But again, it's just another mechanism now for handling these errors. We use the except keyword to catch a specific error, but we don't have to handle it more than that. We can just pass on doing something further. Let me pause here and see if there's any questions now on try, except, else, or pass? Any questions here? Yeah, let's see. Patrick?
Hey, you can hear me, right?
Yes.
Okay, yeah, no, I was just kind of curious, I guess, about the idea of when you were indenting with the getInt function, for example. Because I'm noticing, you know, obviously going through it with the whole logic and breakdown of the entire function, you know, while true, do this. But I'm just kind of curious on elaborating with the indentations for the code more.
Yeah, so the indentation is deliberate logically. Some languages don't require as rigorous indentation. You can use curly braces or other symbology to make clear what is associated with what. In general, anytime you indent something in Python on this line, anytime you write a line of code in Python that's here, and the lines below it are somehow indented, that means that those lines are somehow associated with that first line. And presumably, those indented lines should only be executed if the first line told the computer to do so. So concretely, what does this mean? On line 6 here, we're defining a function called getInt that takes no arguments, colon. Everything that's indented by at least 4 spaces hereafter is part of that function. Why? That's just the design of the Python language. Frankly, I think the designers got tired of seeing really ugly code in languages like C and C++ and Java that don't necessarily enforce indentation to this extent. So now it's baked into the language. And my chronology might be a little off there, but there's been many languages that are looser than Python when it comes to indentation. The indentation is meaningful on line 7 too. Notice that because the while true is indented by 4 spaces, that just means it's part of the getInt function. But notice below the while true statement, there's 8, there's 12, there's 8, there's 12 spaces here. And I'm just quickly counting the dots. That means that all of the lines I've just highlighted are inside of that while loop. While true means to execute lines 8 through 11 potentially again and again and again. And now lastly, on line 8, because we have try and indented below it is line 9, that just means that what you should try is what's on line 9. And similarly, on line 10, below it, we have indented line 11. You should only pass when there is an exception of a value error. So the indentation just means what is associated with what. And once you get comfortable with that, you'll see that it helps, the indentation alone helps explain the logic of your program. And it has a wonderful side effect that for yourself the next morning, for your colleagues, your family, your friends, your teachers, your code is much more readable as a result. It's not one big mess of a blob of text. Other questions now on try, except, else, or pass. Yeah, over to Henrique.
Hello. When you took off the return and the break, you put this thing for where to the pass instead of the return that was before.
The pass replaced the print line. So if I rewind here, notice that all I replaced earlier was this, highlighted on line 11. I was just printing what I decided was kind of an obnoxious message to keep telling the user x is not an integer, x is not an integer. By using pass, I stay in the loop again and again, but I don't bother doing anything. And the reason for pass is this. This would be ambiguous. Python does not allow this. If you just have nothing underneath the indented except value error colon, Python doesn't know, well, wait a minute, did the programmer forget to finish their thought, or do they want me to do nothing? So pass is just an explicit way of saying, I know what I'm doing. I want you to pass on doing anything further. You cannot just leave a blank line. All right, lastly, one final question on try, except, else, or break. Let's see. Joaquim?
Yeah, thanks. Two question. Question one, once you say pass, can the caller still learn anything about this error through a system variable or whatever? And question two, problem set 0 referenced some string methods, including is numeric. Is it any different to go via is numeric here?
A good question. So on the first question, if I'm handling the error in this way, the caller is not going to know anything about it. That's the point of my handling it, so that main or other callers don't know that anything technically went wrong. On the second question, is numeric is another function that you can call that can look at a string and determine, is this in fact a number? I could use a mechanism like that. I could use a conditional. If this looks like a number, then pass it to the int function and go ahead and convert it to an integer. That's totally fine. I would generally say that the Pythonic way of doing things is often, for better or for worse, to try things, hope they work, but if they don't, handle the exception. So other languages are more in favor of checking if, elif, else, and all of these conditionals. Python tends to be a little more of the mindset, try it, but just make sure you're handling the error. So this would be the Pythonic way of doing it. Your way, though, checking with a conditional, is it a number first, is totally reasonable too, if you want to go that way. Well, let me propose some final refinements to this program that really just kind of tighten things up one additional step to improve the implementation of this getInt function. Let me propose that we not hard code, so to speak, that is, type manually x all over the place. Let's make this function getInt a little more reusable. Right now, notice that I'm just kind of using the honor system that, well, main is defining a variable called x. And getInt is asking for a variable called x. But it would be nice if the caller, main, doesn't have to know what the callee is naming its variables, and vice versa. So caller, to call a function means to use it. The caller is the function that's using it. The callee is just the function being called. It would be nice if I'm not just hoping that x is the same in both places. So let me propose this. Let me propose that we actually add a parameter to getInt like this. What's x? That is to say, if main wants to use the getInt function, well, then main should probably tell the getInt function what prompt to show the user. Just like the input function, recall, that comes with Python, it's up to you to pass in a prompt that the user then sees when the human is asked for input. So how do I make this work here? I can go down to my definition of getInt, and I can say, all right, getInt is going to take a parameter now called prompt. I could call it anything I want, but prompt in English is pretty self-explanatory. It means what do you want, the message the user will see. And now down here, when I actually use input, I don't have to presumptuously say what's x, because what if the program, the caller, wants to ask for y or z or some other variable? I can just pass to input whatever prompt the caller has provided. So now I'm making more reusable code. It still works just the same. I haven't changed the functionality per se, but now it's a little more dynamic, because now getInt doesn't have to know or care what variable is being asked for, what's being asked for. It just needs to know what prompt it should show to the user. So if I now run this program down here again, prompt number.py, enter, what's x? 50. Still seems to work. Let's run it again. Let's type in cat. It still seems to work. And if I type in cat, dog, bird, or anything else, it will keep prompting me with that same prompt, making this code, therefore, all the more usable. So in the coming days, the coming weeks, the coming months, as you write more code in Python, you'll see that errors are inevitable. Sometimes there's syntax errors, which you got to just fix if you even want to run your program at all. But they could be name errors. For instance, variables that you meant to define but somehow didn't. Value errors, where maybe the user didn't cooperate and provided you with something that you weren't expecting, or a whole list of other possible errors or exceptions. But now, hopefully, you know how you can handle these errors and respond to them in any way you like. This, then, was our look at exceptions, and we'll see you next time. Minutes. Sure. We'll be back in 10 minutes. We're going to take a 10-minute break, and we'll come back for the second lecture on libraries. So see you in 10. All right. If you can hear this, thought we'd just take a few questions before we begin formally with libraries. Anyone have any questions about what we just did or things we did last time or Python more generally? Probably can't answer everything, but we'll try to take a few here. Yeah, let's see. Tolu, if I'm saying it right?
Yes, you are. When you are using the try and except statements, don't you need to have an idea or an understanding of the error itself before you can actually try or have an idea what to try?
You do. In this case, I added the exception in response to having messed up. So I therefore knew what I was looking for. But that's not always going to be the case. And that's certainly not the best strategy. Because if you're just kind of crossing your fingers that nothing goes wrong, and when something does, then you go fix your software, you're going to annoy a lot of users. Frankly, Python's documentation is not good, ironically, confusingly, at documenting what exceptions can happen from certain functions. Python programmers tend to know, they tend to learn over time. Third-party libraries, which we're about to discuss, those tend to be a little better, I dare say, at documenting it. I don't know why this is the case, but it's a pet peeve of mine. So in general, look first to the documentation for what you should be accepting. You shouldn't be taking the approach I took, which was pedagogically deliberate, which was, ooh, how do I fix this error I just discovered? Oh, and just to elaborate too on that, there is a way lazily to handle all possible exceptions. You just omit value error and you say except colon. Generally, that's frowned upon because it really means like you don't know what you're detecting, even though it does potentially solve a problem. But it's bad practice. Yeah, Vishal, if I'm saying it right?
Yeah. Thanks for having me, first of all.
Sure.
Are you able to hear me?
Yes, we can.
Right. I missed some of your earlier lectures, although I'm able to catch up because I did attend a couple of lectures of CS50 of yours. But any advice of how do I catch up or how do I keep up with, although I am able to understand almost all the things that you're telling us, but still I just want to know what can I do because I've missed the earlier lectures.
Totally fine. I mean, these lectures are live and open while we create them. Technically, you missed 3 weeks of school, but all of it's online. Carter, do you want to paste the edX link and also the OpenCourseWare link? Everything's already available, and officially only the first week is up. We're releasing them 1 week at a time to give us a chance to refine everything, so not a problem. Look for a message in the chat from Carter. Let's see, Nikita, if I'm saying it right?
Yeah, actually, I was not able to submit my problem set 0 because I think submit receipt is not available on Windows or what's happening there. So I was just confused on that part.
Let's see. I'm having trouble hearing your audio. Carter, did you hear that okay? Do you mind just the audio here is a little bad. Do you mind typing it into the chat and I'll ask Carter here?
Yeah, yeah.
Okay, I'll come back to that in just a moment. Carter's going to watch on the chat. And Rangshin, maybe one other hand? And then we'll forge ahead. And yeah, as you'll notice, there's these delays with Zoom. In the post-produced version that will eventually post online, like all of these delays get removed. Rohit, question.
Hello, can you hear me?
Yes.
Can we solve multiple errors in one line of code?
Multiple errors, no. If you mean exceptions, you can have multiple except lines. You can say except value error, except name error, and so forth, line by line by line, if that's what you mean. But not, well, you can also catch multiple exceptions on the same line. Let me just show you real fast over here. You can, instead of doing try this, except foo, do this. You can do this as well. You can say except foo bar. You can say foo bar baz if each of those are exceptions. So you can do multiple things at once. Or you can do except foo, do this, except bar, do this. If that's what you mean, you can handle multiple things together or separately in exceptions. All right, and let me see, Carter, were you able to hear the question? Okay, do look for Carter, the question that was just asked Nikita. Ask Carter if you would like, my colleague who's here on his laptop. I can't see the chat window in front of me, but he can hopefully try to answer. All right, give me just a moment to get reset, and we'll dive in a moment for libraries. This is the second of 2 lectures. We're not going to go on for like 5 hours today. It's just this one final lecture. So hang in there if you're sleepy, but no worries if you want to catch up later. Give us just a moment to get ready. No, ready when you are. But give me just a moment to think. And at the end, let's do a little Q&A too afterward, Patrick, just like that. Okay. Okay, demonstrate. Okay. Okay, ready when you are.
Okay, you're good to go.
Okay. All right, this is CS50's Introduction to Programming with Python. My name is David Malan, and this is our week on libraries. So libraries are generally files of code that other people have written that you can use in your own programs, or a library is code that you've written that you can use in your own program, but maybe not just this program, but another and another as well. So Python supports exactly this idea, this ability to share code with others, share code across your own projects, and it does so by way of what it calls module. A module in Python is just a library that typically has one or more functions or other features built into it. Generally, the purpose of a library, or a module specifically, is to encourage reusability of code. If you find yourself using the same types of functions again and again, the same functionality, if you find yourself copying and pasting from an old project into your new project, odds are there's an opportunity there to factor out that code that you keep copying and pasting, that you keep reusing, and put it into a library that you can then load into your programs moving forward, so as to not just copy and paste it and have all these different copies all over. So what are some of the modules or libraries that Python comes with? Well, Python comes with a random library, literally, which is to say that when you install the Python interpreter on your Mac or PC or somewhere in the cloud, not only do you get Python, you get a whole bunch of modules as well. Now, these modules provide you with functions that you don't have access to just by default, like you do print and input. Print and input and other such functions just work in Python. But sometimes functions are tucked away in these modules, so you have to be more deliberate about loading them into the computer's memory. So somewhere on the computer's hard drive, once you've installed Python, there is also, it turns out, a file probably called random.py that someone else wrote, probably long ago, but that you have access to. And in that random.py file, there's probably one or more functions that you yourself can use in order to do things randomly. That is to say, how could you flip a coin in a program in Python? How could you pick a random number between 1 and 10 in Python? Well, you need a bit of randomness. And while you could figure out mathematically how to write functions like that yourself, it's a lot easier to stand on the shoulders of others who've already solved that problem for you, so you can focus on the problem that you yourself want to solve. So for documentation on most any Python module, you go to the official Python docs, and you go to a URL like this where the documentation for that specific module lives. And within the documentation, you'll see a list of the functions or other functionality that some module provides. But how do you go about loading a module into your own program so that you can use the functions in that module? Well, we need a new keyword in Python, and namely, it's import. The import keyword in Python allows you to import the contents of, the functions from, some module in Python. Well, how might I go about using this in practice? Well, let me propose that there exists in that random module this function, among others. So I have copied and pasted from the documentation this summary of a function called choice. Now, the function exists in the random module so to speak, not a random module, the random module. And so generally the documentation describes it fully like this. Random.choice is how you would technically call this function, though we'll see alternatives to that. In parentheses, there is a parameter called seq for sequence. And sequence generally means a list or something that is list-like, if you have a list of numbers or strings or anything else. And the documentation elaborates. Well, how can I go about using this function to solve perhaps a familiar problem? Well, let me go ahead and open up VS Code here. And let me propose that we implement a program that simulates flipping a coin that in the US heads heads or tails, the idea of which is to pick a decision with 50-50 probability. 50% probability of heads, 50% probability of tails. Or you can use some other mechanism like that. Well, let me go ahead and open a program with code called generate.py, because I want to start generating a whole bunch of random information. The first of which is just going to be a coin toss. Now, how do I go about using that function? Well, I first have to import the random library. So literally the first or among the first lines of my file should be import random. And that just gives me access to all of the functions in that specific module. Now suppose I want to flip a coin. Well, I can do random.choice per the documentation a moment ago. And that again takes a sequence. What's a sequence? It's a list or something that's list-like. And we know about lists. We've used lists to iterate over numbers. We've used lists to iterate over students at Hogwarts. Let's go ahead now and iterate over just a list of two sides of a coin. Heads, quote unquote, or tails. Now I could call these anything I want. These are my strings. I just want to simulate a tossing a coin, so I'm just going to say in all lowercase heads and tails. But notice the syntax. I have heads and tails in double quotes. That's because they're strings. I could also use single quotes so long as I'm consistent. There's a comma between them, which means the list has two elements. There's square brackets to the right and the left, which indicates that this is indeed a list. That's the syntax, recall, for defining a list in Python. And then lastly, there's something more familiar. There's the parentheses outside of those square brackets, but those are just the parentheses that belong to the choice function and specify where its parameter gets passed in. But again, unlike past functions, I have to specify what module this function is in, at least for now. And so I do random.choice to call this specific function. All right, well, it's one thing to flip a coin, picking between those with 50% probability. And that's what random.choice does. It takes in a list, and it returns to you one of those values randomly with equal probability. Because I've passed in 2 items, I've got a 50-50 chance. If I passed in 3 items, it'd be a 33% chance for each of those items, and so forth. Python does the math for you. But I want to store the value of this in a variable. So let's define a variable called coin equals whatever the return value is. So this is indeed like flipping a coin. I'm going to store in a variable called coin whatever that value is, heads or tails. And now just so I can see what's going on, let's go ahead and print out the value of that string coin. All right, let me go ahead now and run this program in my terminal window. Python of generate.py, enter, and it looks like the first coin toss was the heads. Let's go ahead and run it again, and it looks like it was heads again. Maybe you want to chime into the chat here. If I run it a third time, what's it going to be this time? If you want to type your thoughts in the chat. You might think there's a bug here, but this is probability in action. If I go ahead and hit enter a third time, there, it's actually now tails. And again, 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 heads. Now, if we did this an infinite number of times, it would indeed work out to be 50-50. If we only do it a few times, it might not work out as cleanly. But that's how probabilities indeed work. All right, so I've got that now working. Could I have implemented this in a different way? Well, let me show you an alternative to actually using the import keyword alone. And let me introduce the keyword from in Python. So from is a keyword in Python that you can use when importing functions from a module, but it allows you to be a little more specific than import alone. So if I go back to my code here, it's worth noting that what technically I'm doing here by importing random is I'm technically importing everything that's in that module. So not just the function called random.choice. So it's important to note that when I import random at the top of this file, I'm importing the entire contents of random and giving myself access to all of the functions therein, not just random.choice, but a few other functions as well. If, though, that could be slow, and sometimes modules are so big, so powerful, that they might actually add a split second or even longer of startup time to your program, you might not want to import the whole module, and so instead you might do this. From the random module, import the choice function specifically. So now Python's going to be a little smarter. It's only going to give you access to the choice function, but nothing else that's in that same module. But I have to change my syntax now. Now this also allows me to do this. This allows me to execute choice without having to specify what package it's in. So another upside of this approach here is that I am, sorry, let me think for a second before we fix this. Let's rewind. Apologies, this is what happens when it's live. Let me rephrase some of my comments here. All right, let's rewind to this. So instead of calling import So instead of using this line of code at the top of my file, import random, which will technically give me access to all of the contents therein, a downside of that is that I have to type in random.choice, random.this, random.that, because all of the functions I'm calling have to be associated with the scope of that module. Well, suppose that I just want to call the function as its name, choice. I can do that as well. Let me replace this first line here with from random import choice. And what this does effectively is it loads the function's name, choice, into my current namespace, into the scope of the file I'm working in. What that means is that I now no longer have to specify which choice function I mean. I can just say choice. And so it loads it into the local namespace, that is, into my local vocabulary, if you will, so I can just now say choice. This might be advantageous in what cases, do you think? When might you want to import the name of the function explicitly like this, as opposed to just saying random.choice throughout your code when calling a function? Any instincts here for this alternative import using from? Yeah, over to buffering. Okay. Mohammed.
Hello, I'm Mohammed Omar from Egypt. Maybe if we have a variable that its name is basically like choice, if I have a variable called the choice, so I need to differentiate which choice I choose. So I'm going to choose random.choice.
Perfect. Really good instincts. Yeah, really good instincts. By using the first approach, by just importing random, you're making sure that all of its contents are associated with, are scoped to the random module, so that you can have your own choice function. You can have your own choice variable. You can use the same names as all of the functions or variables that are stored inside of that file without them colliding, so to speak. And this is a good thing. In older languages, it was the case that if you imported someone's library, you better hope that you're not using the same functions or variables as they are, because you might in fact have some kind of conflict. Python and certain other languages allow you to scope the names of those functions and variables to the file or the module that they come from, so that's a good thing. But honestly, this is such a short program. Or, equivalently, maybe I'm using the choice function in so many places, calling random.choice, it's just making my code longer and longer and longer. Marginally so, but it's just getting ugly and annoying. I can simply import choice and now tighten up my code a little bit. So as with so many decisions in the past, there's not necessarily one right approach or another. It depends. But I think for those very reasons, sometimes it's better to do what we did the first time, which is only import the module so as to retain the scope therein. Well, let me propose that we transition to another function that comes with Python's random module. And that's this here from the documentation, randint. It's a bit hard to say, but it implies get back a random int. And if you read the documentation, it's a random int that's between A and B inclusive. So if you were to pass in 1 for A and 10 for B, you would get back a number between 1 and 10 inclusive, including the 1 and including the 10 potentially, each with a 10% probability. So how might I go about using a program like this? Well, let me come back to my generate.py file. And why don't we go ahead and try generating a random number between 1 and 10. You might do this frequently in the real world when you just want someone to pick a random number. You tell them as much and the human responds. Let's get the computer to do the same here. Let me go ahead and delete my 2 lines of code at the bottom, but keep my import random. And let's go ahead and define a variable, this time called number. Set it equal to the return value of random.randint. And now pass in A, a value of 1, and B, a value of 10. And now let's go ahead and print the number. I'm going to go ahead in my terminal window and run Python of generate.py and hit enter. 4, Python of generate.py and hit enter. 8, again, 9, again, 7, again, 10, again, 2, again. And we can do this all day long. And if we add all of those up, they should end up being with 10% probability each. Now, how might you use this information? Well, maybe we're playing a guessing game, or maybe we're trying to randomize the behavior of some character in the game. You can imagine using very simple building blocks like this, just kind of spicing up your program by getting it to do things a little less predictably because you're choosing these values seemingly randomly. And you're deferring to Python to actually do the generation of these numbers using its own algorithms and its own math. Well, what more could we do here? Let me propose that we introduce another function that comes from this random library, yet another that you yourself don't have to implement, shuffle. If you read the documentation for shuffle in the same random module, you'll see that it takes in a list, for instance, of values and just shuffles them up. It randomizes them. Like a deck of cards here, you might shuffle them so as to put them into seemingly random order. Well, how do I use this based on this function's name? Well, let me propose that we go back to VS Code here, and let me go ahead and this time do the following. Because I need to shuffle something like a deck of cards, let me go ahead and not just import random, but let me give myself a variable called cards that's going to be of type list. And just so I have something to shuffle, I don't need all 52 cards in a typical deck. I'm just going to shuffle 3 cards, a jack, a queen, and a king. I could call those strings anything I want, but I just wanted a list of some values so as to shuffle them up. That is, randomize the order they're in. Well, how does this now work? Well, if you read the documentation for random.shuffle, you'll see that it shuffles the argument in place. That is, unlike many of the functions we've seen, it doesn't return to you a value that contains the shuffled cards in this case. It actually shuffles the list it's given itself. So what this means for my code is that I need to do something like this. Random.shuffle and pass in the variable containing those cards. And then on a final line here, how might I go about printing the cards? Well, I could do this, and I could say print cards. But if I do that, I'm actually going to see Python syntax for lists. And it's just going to format it in its own way using commas and the like. I want to print these cards out one at a time just because I think it'll look a little better. So we can use some of our syntax from loops and say something like this. For card in cards, go ahead and print out the current card. So what's now happening here? Line 3, I'm defining a list of 3 cards in this order, jack, queen, king. I'm then shuffling those same cards on line 4. And then on line 5, I'm using a for loop. For each of the cards in that list, print it out one at a time. And because I'm using print, one line at a time. Well, let's see the results. Down here in my terminal window, I'm going to run Python of generate.py and hit enter. Queen, king, jack. Seemingly shuffled because that's not the order I defined earlier. Let's do it again. Queen, king, jack. OK, that happens to be the same, but let's see. This could just be bad chance. There we go. Jack, queen, king. Doesn't look like it's shuffled, but at least we're getting back different orderings now. Again, jack, queen, king. Not so good. Jack, queen, king, not so good. This is someone you probably want to play against with cards. Queen, jack, king, there we go. But of course, we only have 3 cards here, so there's not that many permutations we might see. And if we do this over time, we will see all of them. But if we had, of course, 13 or 52 cards, we'd see a lot more permutations instead. So we have now these 3 ways to generate random information. One is simple coin toss if you want to start some kind of athletic event. One, pick a number between 1 and 10 if you want to decide something based on that. And now using shuffle, we can even take in a list of things and shuffle them about so that we get some kind of random behavior. Well, let me pause here and see if there's any questions yet on random, on modules, or any of these 3 functions. Yeah, over to Ganesh, if I'm saying it right.
Yes, thanks for giving me the opportunity to ask you the question.
Sure.
So my question is different, but I would like to ask you, what is the difference between library and header files? As I'm learning C in my classes, so I usually saw that sometimes sir used to say like library or header file. So what does it difference?
I heard library. What's the other word you're saying? The audio is a little quiet.
Header files.
Enterprise?
No, header files. HEADERFILE, header file.
Sorry, I can't hear. Header file. Okay, header file. I'm sorry, the
Yeah.
speaker's a little quiet here. What is the difference then between libraries and header files? So a library is perhaps the most generic term. It refers to code that someone else has written, perhaps even you, that you can use and reuse in your own projects. A header file is a feature of languages like C and C++ and some other languages that simply specifies, among other things, the functions that have been implemented for you. But in a language like C, your code would generally be in a file like something.c. That's where you actually implement those functions. But in C, you would have another file called something.h, a so-called header file. And that contains only the names of those functions and a little more detail that essentially teaches the compiler, the program you're using, what functions will exist. Some languages, like Python, don't make that distinction between your header files and your actual code files. Rather, it's all in one file, like something called random.py. That's in some sense a little more convenient for programmers, and so not all languages take that header file approach. But a header file is something very specific and technical. A library is the general term and indeed the focus overall today. Other questions on libraries or Python modules here? Dinesh? Let's see, Dinesh?
Hello.
Hello.
Yeah, can we increase or decrease the probability of cards if we want to? For example, there is a 33% chance of probability. So is there any chance to increase or decrease the probability?
Are there any functions that do what with the probability? Did you guys hear?
Yeah, if we want to increase the probability for Jack, can we do that?
Can you calculate the probability of a deck?
No, I want to increase the probability of Jack, for example, like Jack 40% and other Queen and King 30.
I see. Rungshin? Set the probability. Oh, can you set the probability? I'm sorry, it's hard to hear down here today. Can you set these probabilities, not using these same functions? Can you set the probabilities? But you can absolutely implement some of your own functions or use more sophisticated functions that do exist in this library and others to exercise more control. These are meant to be very user-friendly and simple functions, certainly the ones we looked at, that give you equal probability for all of those. But absolutely, you could skew things, though hopefully if you're implementing a gambling game or the like, you're not actually making some cards more probable than others. Allow me to turn back now to our implementation here of this randomness and consider how we might leverage other types of functionality that aren't necessarily in this specific library here. Well, it turns out that Python also comes with a statistics library, and this contains all sorts of functions for doing things more statistical in nature, namely calculating means or medians or modes or other aspects of a data set that you might want to analyze. So how might we use the statistics module in Python? Well, we might first just take a look at its documentation like any other module in Python, and we'll see within that library that there's a whole bunch of functions. And one of those functions is one that's quite simple. It's average, a function that allows you to calculate the average of some numbers that you've passed in. Well, let me propose that we implement here a new version of, let me fix this. Sorry. Well, let me propose that we create a new file here with code average.py that simply calculates the average of some number of values. So at the top of this file, I'm going to import, as before, sorry, do this again. Apologies. Let me go ahead and in VS Code in my terminal window, open up a new file called average.py. And at the top of this file, I'm going to import a different library this time, namely the statistics module in Python. And now I'm going to go ahead and call a function that I know comes in that module, namely mean, for the average of some values. And I'm going to call statistics.mean. And I'm going to pass into this function mean a list of some values. And let's suppose that I'm quickly trying to calculate what my current grade average is in school, and I did really well on my first test and I got 100%, and on my second I did well but not as well and I got a 90. And Ironically, I'm not very good with math, so I'd like to figure out what my average now is between those two tests. So let me go ahead now and in this list, type in the number 100, 90, thereby passing in a list of two values, two ints, 100 and 90, and outside of those are the parentheses, because of course this is now the argument I'm passing to the function called mean, and this function mean is in the module called statistics. Well, it's not that interesting to just calculate the mean if I don't actually see what it is. So let me additionally pass the return value of that mean function to the print function as usual, so that now when I run Python of average.py, I see in my terminal window here. Oh, interesting. Let me now in my terminal window in VS Code type in Python of average.py and hit enter, and voila, as you might expect, my average is 95%. So the difference here is that I'm just using a different module that still comes with Python, but I need to import it instead of, for instance, the random module instead. And this time I know from the documentation that there exists a function called mean. Well, it turns out there's even more functionality that comes with Python and that comes with other modules in Python. And there's this feature generally known as command line arguments. This is a feature not just of Python, but of languages more generally that allow you to provide input, not when prompted inside of a program, as happens whenever we call the Python function input, but rather there's this feature, command line arguments of programs, that allows you to provide arguments, that is input to the program, just when you're executing it at the command line. So up until now, for instance, recall that we've generally run Python of something.py. For instance, Python of hello.py. And I've never once really executed any words or phrases after the name of the file. But I could. In fact, when you're running programs in a command-line environment like we are, you can provide any number of words or numbers or phrases after the command that you're typing, and all of those will somehow be passed in as inputs to the program itself. You don't have to prompt the user for one thing at a time by manually calling that input function. So what does this mean in real terms? Well, let me go ahead back into VS Code here, and let me propose that we consider how we might leverage a certain module. I'm going to go ahead and create a file called name.py. And I'd like to use a new module this time that's going to give me access to values that have been typed at that command line. But what's this module going to be? Well, this one's going to be called Sys. And Sys, short for system, contains a whole lot of functionality that's specific to the system itself and the commands that you and I are typing. The documentation for this module is at this URL here, and it lists all of the various functions and variables and the like that come with that module. But we're going to focus on something a little more specific, namely this thing here. It turns out in the Sys module in Python, there is a variable that just magically exists for you called argv. It stands for argument vector, which is a fancy way of describing the list of all of the words that the human typed in at their prompt before they hit enter. All of those are seemingly magically provided to you via Python in a variable called sys.argv. This variable is a list, which means that the first element's going to be the first word that you typed, the second element's going to be the second word that you typed, and so forth. And by way of this list then, can you figure out what words did the human actually type at the prompt and maybe use that to influence the behavior of your own program? So what does this mean now in real terms? Oh, sorry. So what does this now? So what does this mean now in real terms? Well, in this new tab called name.py, let me go ahead and import sys. Within that sys module is going to give me access to sys.argv, but how might I want to use it? Well, let's do this. Instead of writing a hello world program that all of these times has just looked for the return value of input to figure out what the user wants me to print, let's go ahead and just expect the user to tell us when they run the Python program itself what their name is. And suppose this time I'd like to generate a whole bunch of name tags, initially just one, and in the US here it's very common to wear a sticker on your lapel that says, hello, my name is David, so I want to print out some text that resembles that. The idea being maybe I could enhance this program someday to even send that text straight to the printer and dynamically generate those name tags. Well, let me go ahead now and do this. Let me go ahead and print out, as always, hello, but I'll say a little something more this time to make things more interesting. Hello, my name is, quote unquote. And then after that, I normally have been in the habit of calling input storing the return value in a variable and passing in the name of that variable here. But I'm going to instead jump right to this, sys.argv bracket 1. And that's it. I'm going to have a program here that says, hello, my name is, followed by whatever is in sys.argv bracket 1. And notice sys.argv again is a list. And recall from our discussion of loops and intern lists, we use this square bracket notation to get at the various elements inside of a list. Well, let's go ahead and run this program and see what it does. Python of name.py at the prompt is going to give me this. Python of name.py index error here. Well, index error, list index out of range. Well, what's going on? Well, actually, let me think to myself if we want to do that. Nope, let's rewind and not trip over that yet, lest we cloud the example. All right, let me go down now into my terminal window and run python of name.py. But this time, rather than just hit enter and wait for the program to prompt me for my name, let me proactively just tell this program what my name is at the so-called command line. Here we go, david separated with a space from the name of the file, so that now when I execute python name.py David, I see on the screen, voila, hello, my name is David. So based on this demonstration alone, I think we can infer exactly what's going on in sys.argv, even though it sounds certainly, at first glance, rather complicated here. Let's look up. At sys.argv, I'm going to bracket 1 here. So clearly, sys.argv bracket 1 is storing david, but it's 1. In the past, when we looked at loops, recall that we said that they were 0 indexed. That is, the first element is 0. The next element is 1. This next element is 2, and so forth. And yet here I am treating it as though my name is at the start of the list 1. Well, let me ask this question. What is probably in sys.argv of 0? What is probably in sys.argv of 0? The very first element actually in that list. Philip, your thoughts?
Yeah. I think it's like in C, the name of program.
Indeed. It's indeed, like in C and other languages, the name of the program. Well, if we consider what it was I typed, I certainly typed Python, because that's the name of my interpreter. And we don't really need to know that, because we're using Python itself. But after that, I did type 2 things. I typed name.py, as I've done so many times, anytime I want Python to interpret a program I've written. And it turns out by convention, what Python does is it stores in sys.argv the name of the file that you're executing or interpreting, followed by any number of other words that you typed. So all this time, we could have been accessing the name of the program, which frankly isn't all that interesting, but we can also now access words that are typed after that prompt as well. But of course, if I don't type anything in, what might happen here? This might be naive of me to assume that there's always going to be something at location 1 in sys.argv. Let me go ahead and try this. Python name.py. And no, I'm not giving you my name, because at this point I might not even know that you want my name to be typed. So let me hit enter now. And uh-oh, we see now an error. A so-called exception in Python. This one's a new one. This one's an index error that elaborates list index out of range. And turns out this is actually one of the most common mistakes in programming, whether using a list in Python or arrays or vectors in other languages, is to try to access some element that does not exist. You try to go too far to the left, or you try to go too far to the right in this object that is just a list of some values. So of course, the mistake here is that I'm assuming there's going to be something at location 1 when really it's location 0 that's the only one that has a value. But fixing this is not going to amount to doing bracket 0, because now if I go ahead and rerun this program with no other words after name.py, it says, hello, my name is name.py, which is fine if we're making a name tag for the program, but that's not, of course, what my goal here is instead. So if the fix is not just to change the 1 to a 0, how else might I handle this error? How else might I handle this error? This index error that happens if the user just doesn't remember to or doesn't know to type their actual name at the prompt. Yeah, Piyush, your thoughts?
We could always put an exception into the program saying if there's nothing at location 1, we just come out to say, well, okay, we haven't got a parameter or something. But if there is, you continue along with the program.
Perfect. So if I might simplify, we can try to execute this line of code, except if there's an error, we'll deal with it in some other way. Now, ideally, and once I'm a strong enough programmer, I would have anticipated this and written the following code from the get-go. But when you're learning, it's certainly reasonable to see an error. Oh, I didn't realize I should detect that, and then go back and improve your code. But of course, if you read the documentation, you ingrain some of the lessons learned from the past, you'll get into the habit of trying and checking for some of these exceptions yourself. So let me solve this in one possible way, as you proposed here. Let's try to handle this exception as follows. Let me go ahead now, and instead of just blindly calling this print line, let me try to print out, hello, my name is such and such, except if there is an issue, specifically an index error, then what do I want to go ahead and do? I'm going to say something like too few arguments. I could be more explanatory than that, but for now, I'm just going to explain to the user that they gave me too few arguments, too few words at the prompt. So now, it's still not going to work in quite the way I want. I'm still not going to be able to generate their name tag, but at least they're not going to see some cryptic error message and think that they themselves broke the program. Let me go ahead now and run python of name.py, enter, and too few arguments. OK, let me go ahead now and do python of name.py and type in my name, David, and now we're back in business. And I see that my name is on the screen too. But strictly speaking, I don't have to try to do this. I could actually be a little more defensive in writing this code. And maybe I could check whether or not the user has indeed provided a name or multiple names at the prompt so as to give them more refined error messages as well. So how might I do this? Well, let me go and undo the exception handling I've added. And why don't I instead more modestly try to do this? Let me go ahead and introduce a conditional here. If the length of sys.argv is less than 2, or equivalently equal to just one value, but I'll just stick with less than 2 for now, then go ahead and print out too few arguments. So I want ultimately 2 arguments. I want the name of the program at location 0, and I want the name of the human at location 1. So that's a total of 2 arguments. So if I have fewer than 2 arguments, let's tell the user with this print line, if the length of sys.argv is, say, greater than 2, like they typed in too many words at the prompt, well, let's tell them print, quote unquote, too many arguments. Else, if they did get it right and they gave me exactly 2 arguments, else, let's go ahead and print what I actually care about. Well, let me go down to my terminal window and run python of name.py here and hit enter. Haha, syntax error. OK, let's turn this into a teachable moment. All right, let me go down to my terminal window here and run python of name.py, and voila, a completely different type of error. This one, a syntax error, which we've seen in the past. Now, a syntax error, recall, is mea culpa, like I messed up here and I wrote invalid syntax, and so no amount of conditionals or exception handling is really going to catch this one. I need to go back and just get my program to work because it's not running at all. Well, let me go up here and see. Line 4 is the issue, and indeed, it looks like I have an unterminated string here. I need to go ahead and now add this double quote. So let me go ahead now, and with that red herring gone, let me rerun python of name.py and hit enter, and now we see too few arguments. OK, maybe it wants my full name. Let me go ahead now and run python of name.py, David Malan, typing in both words after the name of the file and hit enter. And now, of course, it's too many arguments. Fine, now I'll oblige and do python of name.py and just David, and there we have it, my name tag printed on the screen. So strictly speaking, we don't have to handle exceptions if we can be a little smarter about it and just check for the things that we're worried about, especially if we want to give the user more refined advice. We don't want to just tell them, no, something went wrong, or we don't want to pass. We want to tell them, no, that's too few. Or no, that's too many. We have conditionals in our vocabulary already via which we can now express that. Well, let me pause here and see if there's any questions now on how we handled the error before with the index error, or how now we're just proactively avoiding all index errors altogether by just checking first, is it too few, is it too many, or is it exactly what we want? Yorgo?
Hiya, thank you. So I was wondering, you touched upon kind of using your full name. Could we then, is there a way going forwards that perhaps we have people that want their full names and want just their first name, that we separate that into like, oh, this person has full name, this person has just the one name?
Absolutely, and allow me to propose we come back to that support for multiple names. But indeed, we could do that. And I should note too, though, we can support full names right now if I do this. Instead of typing in David space Malan, which is problematic because, again, by definition of how argv works, each word ends up in a specific location in the list. But if I add quotes, single quotes or double quotes at the command line, now Python will view this as two total things, the name of the file and this full name. And now when I hit enter, I don't see the quotes. The whole thing is passed in as my full name. And if I want to adapt this further for multiple people, we'll be able to do that as well. Other questions now on this version with if, elif, else, or on except before. Let's see. Artem Swar, if I'm saying that right? I think we're hearing a lot of background noise.
Sorry, my name is Sophia. Hi, my name is Sophia. I was thinking if there was a list or something like that of arguments that we could use while coding, like the same way there is a module, but a module of objects or a module of things that is in a house, something like that, that we could use.
I'm squinting because I'm having trouble hearing you here. Do you mind typing it into the chat so that Carter can relay it to me? I'm afraid your audio is breaking up quite a bit. Let me turn to one other question. We'll come back verbally in a moment if we could. How about over to Subrat?
Hi, sir. I want to ask you, can we use multiple else statement?
Can you use multiple else's statements? No. Else is the last catch-all statement that you can have. You can have multiple if statements in the middle, but not multiple else's.
Okay. Thank you.
All right, well, let's turn our attention back now to this code and see if we can't refine it a bit more by adding in some additional functionality that we get with modules like the Sys module. One of the things I don't love about this version of the code, even though arguably it is now correct, is that the essence of my program, which is just to print out the name tag, is kind of relegated to this else clause. And that's fine. Logically, it's correct. But generally speaking, there's something nice about keeping all of your error handling separate from the code that you really care about. Having all of these ifs, elifs, perhaps at the top of your code that are checking to make sure that all of the data is as expected. But then it would be nice, if only for design's sake, not to sort of hide in this else statement the actual code that you care about. I would prefer, for instance, to do something logically like this. I could check for errors up top, and then down here, print the name tags. It would be nice if those are sort of distinct blocks of code, all of which are here left aligned. But there's a problem with what I've just done here. Logically, what bug did I just introduce by getting rid of the else and introducing line 10 on its own with no indentation outside of the conditional? What bug have I just introduced? What mistake, to be clear? Yeah, let's go to Tolu, if I'm saying it right.
Name error.
A name error. Why do you say name error?
Can you hear me?
You froze for me, but
My
it's not.
line is breaking through.
Ironically, it's a name error, but not a name error exception. It's an error with my name, but I think you're frozen for me. It's going to raise an exception because even though I'm checking the length of sys.argv up top, and even though I'm checking it again for being greater than 2, not just less than 2, but greater, I'm still then blindly and incorrectly assuming it's now going to exist. So just to be clear, if I run python of name.py and I don't type any arguments, I've got too few, I think I'm going to see that I have too few, but I'm also going to see that same exception. At the very top of my terminal window's output, there's my error message, too few arguments. But again, on line 10, I blindly proceed to still index into my list at location 1 which does not exist. So it turns out there's a better way to handle errors like this, especially if you're writing a program in Python that's just meant to run briefly and then exit anyway. But maybe we could start to exit prematurely if the program itself just can't proceed. If the user has not given us the data we want, perhaps we should just exit the program earlier than we might otherwise. So let me go ahead and do this. Let me go ahead and remove my comments so as to focus only on the code here. And let me propose that instead of just printing quote unquote too few arguments, I'm going to use one other function that comes with the Sys module. I'm going to go ahead and call sys.exit. And as the name suggests, it's going to do exactly that. With the system's help, it's going to exit my program then and there on line 4. Why is that OK? Well, if you gave me too few arguments, I have nothing more to say to you, the user. I might as well exit a bit prematurely. And I can do this as well on line 6. Let's go ahead and not just print that, but sys.exit, quote unquote, too many arguments. Print out that message and just exit right there. Now I can trust that by the time I get to line 8, every error condition has been checked for, and so it's safe for me to assume that there is, in fact, an item at location 1 in sys.argv. So let me go ahead now and run this. Python of name.py, enter, too few arguments. But I'm back at my prompt. Nothing more has happened. Let me run it again. Python of name.py, David Malan with no quotes, enter. Too many arguments is now printed here. Finally, Python of name.py, just David, enter. Hello, my name is David. So we have then in sys 2 forms of functionality now. We have access to this variable, sys.argv, this argument vector that gives me all of the words that were typed at the prompt, including the program's own file name. And it turns out, if we read further in the documentation, there's an exit function that can take different types of inputs, but if I pass it a string like this, it will indeed print that string for me and then exit from my program then and there. Questions now on exiting from programs like this. To be clear, all of this time, once Python gets to the bottom of your file, it's going to exit anyway, so I'm using sys.exit now just to make sure that I exit earlier than otherwise. Roderick, question?
Oh, hi. My question is about the sys.argv. So is that capable of accepting or taking multiple elements at once? Let's say, for example, Python name.py, David Malan, I'm a male, 20 years old. And if, let's say, I only want to access your name, which is at the first index, and then your age is, say, at the 6th index, can I say sys.rv1 and another one for 6 to access what I just want? Is that possible for sys.rv?
Short answer, yes, I think, if I understand your question correctly, whereby you're proposing to have many words at the end of the command, and you want to access those individual words. Absolutely. At some point, it gets a little fragile, I would say, if you're typing so many words at the prompt that the order really matters. And so it turns out there's a lot of programs, and there's functionality in Python that can allow you to provide those values, like name or age or any number of other fields, in any order you want, but pass in a bit more information textually that tells the program how you want to use it. So in short, what you're describing is possible. And let me do a small incarnation of it as follows. Let me propose that we go back to my code here, and let's propose that we actually now want to support multiple values at the prompt. So there's going to be no such thing as too many arguments. Suppose that I want to generate name tags, not just for David, but for David, for Carter, for Rongshin, for others in the group who all want their name tags as well. So I'm going to go ahead and do this. I'm going to get rid of my elif condition because I don't want to limit the maximum number of words that are typed at the prompt anymore. I instead want to iterate over every name at the prompt. So I'm going to say this. For arg in sys.argv, go ahead and print out, this time, arg. So what am I doing here? Well, even though the syntax is a little different, the idea is the same as before when we've had loops. I'm using a for loop to iterate over a list. The list in question here is sys.argv. Arg is a variable that I'm creating on the fly. The for loop is going to make sure that the first time through this loop, arg is set to the first word on the command line. The second time through the loop, Python's going to make sure that arg is now set to the second thing on the command line, and so forth. That's just how a for loop works. It updates the variable for us. I don't have to call it arg. I could call it name, so long as I change it to name in both places. But arg is reasonable if I'm iterating over arguments more generally. If I now run this program, though, unfortunately, there's a little bit of a bug. Even if I type in David and Carter and Rongshin, I'm not going to get just 3 name tags. In your mind, does anyone see the bug I'm about to trip over? It's not a huge deal if I've got enough name tags to go around, but I'm going to be wasting one because this is going to print not 3, but 4 name tags, whereby the first contains the name of the program itself. Maybe not a big deal. Maybe that's the sticker we don't bother handing out, but it's wasteful and it does look wrong. So how could we get access to not all 4 elements of argv, but just a slice of argv? And this is actually a technical term. In Python and some other languages, to take a slice of a list means to take a subset of it. Maybe from the beginning, maybe the middle, maybe the end. But a slice is a subset of a data structure like a list. Well, how do I actually do this in code? Well, in Python, it's actually very easy to take a slice of a list, that is a subset thereof. You can simply do this. At the end of the list name, sys.argv in this case, you can use square brackets. And then in those square brackets, you can specify the start and the end of the list that you want to retain. I want to start at element 1, not 0. I want to start at element 1, and I want to just go to the end. So I'm actually going to omit a second number altogether. It's not necessary to have a second number, but I do need that colon because this is going to give me a slice of the list. It's going to give me a slice of the list that starts at location 1, not 0, and the colon and then a blank just means it's going to give me everything else. So this is equivalently going to slice off the first element of the list and give me a new list that contains just those 3 human names, not the name of the file itself. Let me try running this again. I'm going to run Python of name.py, David, Carter, Rongshin. This time, hopefully, I'm going to get 3 and only 3 name tags. Hitting enter, and indeed, I've done now just this. So again, using some relatively simple syntax in Python, we can use square brackets not just to go to specific elements like bracket 0 or bracket 1. We can also get subsets of the list, slices of the list, by doing bracket something colon something, where each of those somethings is a number, the beginning or the end, and they're optional, depending on whether you want all of them or just some. Any questions now on this version, which adds the loop and these slices with that new syntax? Questions on this here? Yeah, let's go over to Melvin.
Can we slice starting from the end of the argument vector?
You can. You can slice something from the end of the argument vector, and this might blow one's mind a little bit. Let me go ahead and do this. Let's see. Let me go ahead and do -1 at the end, using a negative number here and running the same command. We've just uninvited Rongshin from receiving a name tag here. So if you use a negative number, it has the effect of counting to the in the other direction from the end of the list. A good question there. Other questions now on slices, on looping over sys.argv. Yeah, Eric, question?
Hi. So I remember very early on when we were talking about only having 2 decimal places in float value. Is that in the same vein? Like because we use the colon point to f. So is that the same thing then? Why would the f be included then in the point to f as opposed to here when you just have the numbers?
A really good question, and it's just the short answer is that context matters. So there's only so many keys on our keyboard, and so we sometimes use the same symbols for different things. So what you're alluding to is the format code in F-string for actually formatting a number, using a colon, using a period, using a number, using the letter F, and so forth. And that is very specific to the F-string feature of Python. This case has nothing to do with any of that syntax per se. This is just using a colon in a different context to solve this problem to implement a slice. The authors of Python could have chosen another symbol, but honestly, looking down at my keyboard here, we don't have that many to choose from that are easy to type, so sometimes they have different meanings. A good question as well.
Thank you.
Allow me to propose now that we take things further and move away from using only those modules, those libraries that Python comes with, to talk about more generally packages that exist. One of the reasons that Python is so popular and powerful these days is that there's a lot of third-party libraries out there as well, otherwise known as packages. Strictly speaking, Python itself has a term of art called a package, which is a module, essentially, that's implemented in a folder. Not just a file, but a folder. But more generally, a package is a third-party library that I can install on our own Mac or PC or our cloud server and gain access to even more functionality that other people have implemented for us. Now, one of the locations you can get all of these packages is called the PyPI website, the Python Package Index, which lives at this URL here. And this is a website that is searchable via the command line as well as via the web that allows you to download and install all sorts of packages. Even CS50 has some of its own packages in services like these. Now, there's a fun one out there that's a throwback to a command that's been around for years in command line environments called cow_say. Cow_say is a package in Python that allows you to have a cow say something on your screen. If curious to read up on it, its own documentation is on pypi.org, specifically at this URL here. But how do you actually get the package into your system? Well, technically, you could figure out how to download the file and maybe unzip it and put it into the right location on your Mac or PC. But nowadays, a lot of languages, Python among them, has what's called its own package manager. This one here called pip, which is just one. So pip is a program that generally comes with Python itself nowadays that allows you to install packages onto your own Macs or PCs or cloud environment by just running a command, and then voila, you have access to a whole new library in Python that didn't come with Python itself, but now it's available on your system for you. So let me go back to VS Code here, for instance, and let me propose that we first install this very same package. I'm going to go ahead and type in my terminal window, pip install cow_say. So pip, again, is the package manager. Install means to install this package, of course, and cow_say is the name of the package that I want to install. I'm going to go ahead and hit enter. That was not supposed to happen. Teachable moment. Movie magic. OK. Let's go back to VS Code here. And in my terminal window, I'm going to go ahead and type pip install cow_say. Now, what's going on here? Pip is the command, the package manager. And I want to install what package? The package called cow_say. I'm going to go ahead and hit enter here. And after a little bit of output, it has successfully installed cow_say. Now, what does that mean? That means I can now go about importing this into my own code. Well, let's go ahead and see what this means. Let me go ahead and create a new file with code called say.py, because I want something to be said on the screen. And in my new tab here, I'm going to go ahead and import cow_say, which presumably is now installed. I'm now going to import sys as well, because I'd like to use some command line arguments in this program just so that I can run it quickly. And without using the input function, I can get the user's name immediately from the prompt. And let me go ahead and do this. I'm going to do a bit of error checking proactively this time. And rather than use less than or greater than, I'm this time going to say if the length of sys.argv does equal 2. So if the human is provided just the name of the program and their own first name, we're good to go. I'm going to do the following. I'm going to call a function called cow in the package called cow_say, and I'm going to pass in a string, hello, comma, and then, as in the past, I'm going to pass in just one string, because according to its documentation, it's not like print. I can't pass in comma this, comma that. I can only pass in one string, so I'm going to concatenate the contents of sys.argv bracket 1. So long as then I type in my name, David, after the name of this program, it should end up in sys.argv1, in which case this line 5 of code should concatenate hello with my name, with a space in between, and apparently a cow is going to say it. So let's see what happens here. Let me go ahead and clear my screen and increase the size of my terminal window. Let me go ahead and run Python of say.py and type my name, David, and enter. There is the program called cow say. It literally has a cow say something on the screen. And this is a throwback to a program from yesteryear that tended to come with a lot of systems. This is otherwise known as ASCII art. It's a textual way using just keys on your keyboard to print pictures of sorts on the screen. Now, we can really go down the rabbit hole here, and there's questionable academic value of doing so, so I'll do so just once. Turns out the cowsay package comes with other functions as well. One of those functions, for instance, is trex. And if I now increase the size of my terminal window, we'll perhaps see where we're going with this. Let me now run again Python of say.py. This time, let me not provide my name just to see if it's broken. It's still OK, because we have that if condition. If the length of sys.argv equals 2, and only if it equals 2 do we do anything. That's why we're not seeing anything here. Let me go ahead and cooperate now. Say.py space David. And it's no longer a cow, but if I zoom out on my screen, a T-Rex. Why? Just because. These are the things you can do once you know how to program. You can even package them up and make them freely available to others as open source software. For us, it's demonstrative of a feature more generally here, namely being able to install these third-party packages and how you might do so in Python. Now, I'll leave this up on the screen for a moment and see if there's any questions about cows or Tyrannosaurus rexes or packages more generally. I'm really qualified to speak to just one of those. Question from the group here. Yeah, Piyush, question?
Hi, I've got two questions. It's a bit earlier than what's supposed to be. So the first question is, the packages that you're calling to use in the program, are they the same as, let's say, because I'm doing Java, the same as calling a class of a Java file in order to use its functions? And my second question is, what's the actual purpose of using command line arguments as you've used? Because it's not really the best way to, as you say, be user-friendly, where, as in, let's say the person who's using the program doesn't know what they want, what the program's asking them, and they just say, okay, run the program, and nothing happens, and they don't understand it. And then they say, okay, if someone tells them, oh, the program's asking you to print its name, and you have to pass in why couldn't you just prompt the users to say, please enter your name, and then print out his or name, say, hello, my name's this?
Really good questions. The first question about the comparison with Java. Python packages are similar to Java packages, where you have something at the top of your program that gives you access to a class or something else. Python itself supports classes, more on those down the road, and you can do very similar things in Python as you can do with Java. But the analog really is Python packages to Java packages here. As for command line arguments, you ask a good question. Why do we use them, especially if they're a little less user-friendly? They're a little less user-friendly to people who aren't in this Zoom, to be honest. You and I, as we learn more and more about programming and more about command line arguments, I dare say will become more comfortable with and tend to prefer the ability to customize commands using these command line arguments. Why? Productivity. It tends to make you faster because you get into the habit of knowing exactly how you can configure your software without having to manually answer questions. And case in point, all of this time, have we been running Python of something.py. You could imagine not doing that. You could imagine typing only Python, hitting enter, and then you're prompted for the name of the file you want to run. So you type in something.py, and then it runs. Not a big deal, but I would argue that over time, you're going to get a little tired of that tedium, and you would much prefer to just automate the command again and again and again, especially with little conveniences like being able to hit up and down in your keyboard history so as to rerun those same commands. Automation is big too. If you emerge from a class like this and start using Python to automate processes at work or for personal projects or the like, the ability to specify all of your inputs on the one line just means you can get work done more quickly. So hands down, absolutely, using command line arguments is a more arcane feature of systems that most of us are no longer as familiar with because of Windows and Mac OS and other operating systems that have buttons and GUIs and menus. But the more comfortable you get with programming, I dare say the more you will tend to prefer these capabilities because they allow you to do things more quickly. With that said, allow me to propose that we take a turn toward yet another package that's particularly popular and just as easy to install, all toward an end of using APIs. Now, APIs are not something that's Python specific. More generally, an API is an application programming interface, and it can refer to Python files and functions, but often APIs really refer to third-party services that you and I can write code that talk to. Many APIs, but not all, live on the internet these days, so that so long as you have a browser or so long as you have some experience with Python programming or programming in any language, you can write code that in effect pretends to be a browser, connects to that third-party API on a server, and download some data that you can then incorporate into your own program. Now, how do you do this? Well, Python has a very popular package that you can install via pip called requests. The requests library allows you to make web requests, internet requests, using Python code, essentially as though you were a browser yourself. You can automate, therefore, the retrieval of URLs that start with HTTP or HTTPS. The documentation for this library is at a URL like this, but it too can be installed at the command line. And even though it's third party, it's one of the most popular and commonly used packages out there in Python. And this too is one of the reasons, again, that Python is so popular. There's just so many solutions to problems that you and I have or are invariably going to have when we write projects of our own. There's just a really vibrant ecosystem, a really vibrant community of open source software that's that easy for us to install. Well, let me go ahead and use this package as follows. First, I'm going to go ahead and do pip install requests to install requests onto the system if it's not already there and it's successfully installed at the end of this output. Now I have access to the requests library, and this is going to allow me, oh, sorry, let me do that again. Let me go over to my terminal window here first and run pip install requests, which is going to have the effect of installing that library into my system, and indeed it's successfully installed. Well, let me give you the footage you need. Sorry, pip uninstall. This is behind the scenes. This is how you uninstall a package. Now again. Let me go back to my terminal window now and run pip install requests in order to install this package on my own system. And after some lines of output, I'll see that it's successfully installed. Now let's go ahead and create a new file here. For instance, itunes.py. It turns out that Apple, who makes iTunes, a software via which you can download or browse music and songs and other information, has their own API, application programming interface. And better yet, it's not something you have to pay for or sign up for. You can just access it via a browser alone. In fact, let me go ahead and open a browser here, and I'm going to go to this URL here, https://itunes.apple.com/search !entity equals song & term equals Weezer. Now, a bit of a mouthful to be sure, but this URL here is going to allow me to search Apple's API, application programming interface, for all information they have about songs by the band known as Weezer. When I hit enter, what you'll see is that nothing really seems to happen at first glance. Literally, that was not supposed to happen. All right, stand by. Apologies. We are live programming. One moment, please. Oh, interesting. Try that again. Apologies. I'll explain what I'm doing in a moment. Interesting. Function, it looks like limit is required. That wasn't yesterday, though. Sorry, be with you in one moment, internet. Oh, but it didn't need to be there, too. It is working when I do it that way. Entity equals song &. That might, well, that, oh, it's... All right, sorry. Give me just a moment. My apologies. I don't think we need to break. I will just fix this real fast. I swear this worked before, but let's do this in a way that it's going to work again. Limit equals 1. Maybe it is necessary, the limit equals 1. All right, so we're going to do this again. All right, apologies. All right, rewinding. OK, I'm going to go back in a second. Sorry. OK, here we go. OK. All right. My apologies to everyone on the internet. It turns out that Apple has its own API for their iTunes service, the software that provides you with the ability to download and search for music and songs and other information as well. And it turns out that, let me go back over to my computer here and open up a browser like Chrome. And let me go ahead and visit this URL here, https://itunes.apple.com/search, !entity equals song, ampersand, limit equals 1, ampersand, term equals Weezer. Now, I constructed this URL manually by reading the documentation for Apple's API, Application Programming Interface for iTunes. And what they told me is that if I want to search for information about songs in their database, I should specify entity equals song, so that it's songs and not albums or artists or something like that. If I just want to get back information on one song, I'm going to provide limit equals 1. And if the band I want to search for, the artist, is Weezer, I should specify term equals Weezer. So with this, if I go ahead and hit enter and visit this URL, I actually end up with a text file in my downloads folder on my Mac. And if I go ahead and open this text file here, what we'll see is a somewhat cryptic looking file of text. Now, let me do that. Let me give you this footage. If I go ahead and open that text file on my Mac, you'll see a fairly cryptic file here containing a whole lot of text. But we'll see some familiar syntax, which is actually reminiscent of something we've seen in Python itself. We'll see a curly brace over here, and we'll see a curly brace all the way down here. We'll see a square bracket over here, and we'll see a closed square bracket over here, which is to say we're seeing some of the same syntax we see in Python when it comes to dictionaries or dicts, or lists in Python, which is those, do I want to do this? Sorry, let me rewind slightly for our team here. We'll overlay. If I go ahead and open that text file that my browser just downloaded, we'll see all of this text here, which at first glance might look a bit cryptic, but it actually follows a pattern. Notice this curly brace at the start, and notice this closed curly brace at the end. Notice this open square bracket here, and notice this closed square bracket here. And in between those pieces of syntax are a whole bunch of strings and values. In fact, a whole bunch of key value pairs. What we're looking at here is a standard text format known as JSON, JavaScript Object Notation, which, yes, is technically related to yet another programming language called JavaScript, but JSON itself is typically used nowadays as a language agnostic format for exchanging data between computers. By language agnostic, I mean you don't have to use JavaScript. You can use Python or any other language to read JSON or write it as well. And it's a completely text-based format, which means that if I visit that URL with my browser, what gets downloaded is just a bunch of text, but that text is formatted in a standard way using curly braces and square brackets, using quotes and some colons that ultimately contains all of the information in Apple's database on Weezer's song, at least the first one, because I limited it to one, in their database. And that's an API, an application programming interface, a mechanism whereby I can access data on someone else's server and somehow integrate it into my own program. Now, of course, my browser, Chrome, is not something I wrote. I should actually write some Python code that perhaps pretends to be a browser to grab this same data. So let's do that. Let me go back to VS Code here, and let me write a program with code itunes.py. And we're going to write some code via which I can then use the iTunes API and in turn Python to get information about any band that I might want. I'm going to go here and import first the requests library, which I installed earlier in order to make those HTTP requests. I'm going to go ahead and import the Sys library, via which I'll have the ability to use command line arguments like specification of the band that I want to search for, if not Weezer. And then down here, I'm going to go ahead and insert some error checking to say if the length of sys.argv does not equal 2, so if the user does not provide me with the name of the file they want to run and the name of a band, and that's it, you know what, let's just go ahead and exit for now. I could provide a more explanatory message, but for now I'm going to keep things simple and just exit the program prematurely so that I can trust hereafter that sys.argv has what I want. And now I have the opportunity to use the requests library to write some Python code that effectively is pretending to be a web browser so as to connect to that same HTTPS URL on Apple's own server. And I'm going to go ahead and do this. Requests.get, open parenthesis, and an argument now that is the URL that I want my program to visit. https://itunes.apple.com/search. Question mark, entity equals song, ampersand, limit equals 1, ampersand, term equals. Now I could say Weezer here explicitly, but then this program is only ever going to work for Weezer. But that's fine, I think, for now. What do I want to do with the response that I get back from the server? Well, let's assign the return value of requests.get to a variable called response. So to be clear, request is the package that I installed earlier. I've imported it up top, which gives me access to any and all functions therein. The function I've decided to use based on the documentation is called get. Just like a browser would get information from a server, so do I want my Python code to get the same data as well. And then just for now, just so we can poke around and see what's coming back, just like I did on my Mac, let me go ahead and print out, for instance, response.json. If I know, according to Apple's documentation, that they indeed return JSON as the text format in which all of their API's responses are, I can do response, which is the variable storing that data, .json to get the same text format on my screen. Now, this is not yet that useful because I would ideally like to access maybe only the songs that Weezer or someone else has performed. But for now, I just want to see the raw data because I'm learning. I'm going to go ahead now and increase the size of my terminal window, and I'm going to run python of itunes.py. And what comes back from the server? Nothing. Oh, OK. Let me go ahead now and run python of oh, I see what I did. Sorry for the head fake there. Let's do this. Sorry, I'll just want to get this right so we don't have to have the team fix here. OK, I'm just going to rewind a little bit here if folks don't mind. So a little bit of repetition, but also hopefully it'll come out even better this time. All right. So now that I've guaranteed that the user has typed in not just the name of the file, but also the name of a band at the prompt, giving me a length of 2 for sys.argv, let's go ahead and execute requests.get, which is a function inside of the requests package that will literally get some response from a server. And the URL that I want to get is exactly the same as before, https://itunes.apple.com/search, question mark, entity equals song, ampersand, limit equals 1, ampersand, term equals previously Weezer. But let's make this program a little interactive and actually allow the human to specify at the command line what artist they'd like to search for. So I'm going to go ahead and close my quote early and just append, using the concatenation operator as in the past, sys.argv bracket 1. And now it'd actually be nice to store the response from the server in a variable. So I'm going to go ahead and say response equals, and to store all of the response that comes back from the server in a variable called response. Down here now, I'd like to just understand what the server's returning to me to make sure I know how next to proceed. So this isn't going to be very pretty yet, but I'm going to go ahead and print out response.json, which ensures that the data I'm getting back is formatted on my screen as exactly that, JSON, the same text format as we saw on my screen. It's not a useful program yet. I'm really just learning along the way. But let me go ahead now and increase the size of my terminal window and run python of itunes.py and type in the name of a band like Weezer and hit enter. And what we see on the screen, formatted almost the same as before, is exactly that same text. But what you'll see here is that this has been standardized now as a Python dictionary. What indeed Apple's returning is technically a JSON response, JavaScript object notation, but Python, the requests library, is converting it to a Python dictionary, which happens to use, wonderfully coincidentally, almost the same syntax. It uses curly braces to represent the dictionary here, and a closed curly brace to represent the end of it here. For any lists therein, it uses a square bracket here and a closed square bracket down here. It uses quotes, single quotes in this case, or equivalently double quotes to represent the keys in that dictionary. And after a colon, it stores the value of that key. And so you'll see that indeed we have a result count key whose value is 1, but then a more interesting result key called results whose value is this entire list of data. Now, honestly, this is such a big blob of text that it's going to take me forever to wrap my mind around what I'm seeing. So let me propose temporarily we use another library in Python that will allow me to format my data a little more cleanly. It turns out that Python also comes with a special library called JSON that allows you to manipulate JSON data and even just print it. That is, format it in a way that's going to be way easier for you and I to understand. So let me go back to my code here. Let me shrink my terminal window. And let me propose that just temporarily, again, we do this. Let me import this additional library, JSON, which comes with Python. So I don't need to install it manually with pip. And let me go ahead now and not just print out response.json, which was that big blob of hard to understand text. Let me go ahead and use one other function here called json.dumps for dump string, and pass to that function that response.json return value. So again, I'm just introducing another function who I claim it has a purpose in life of pretty printing, nicely formatting on the screen the exact same information. And I know this from the documentation, having done this before. But I'd like things to be nicely indented. And according to the documentation, if I pass in a named parameter of indent equals 2, that's going to indent everything at least 2 spaces. I could do 4 or something else, but it's going to be enough to help me wrap my mind around what the data is I'm getting back. Because again, I'm just learning along with you. So let me increase the size of my terminal window again. Let me run Python of itunes.py. And again, let's search for Weezer and hit enter. And now notice it's still a little bit cryptic because there's a lot going on here. But my gosh, I can totally read this more easily now. Notice now that I still see the first curly brace, which means, hey, this is a dictionary in Python, a collection of keys and values. The first key is called result count. It happens to be displayed in double quotes now, but that's just an issue of formatting. It could be double or single so long as we're consistent. The value of that key is 1. Why? Well, I told the URL to only limit the responses to 1 Weezer song, so I've gotten a result set of 1. If I increase that limit, I could probably get more. Then the interesting part of this response is really the data itself. Notice in the results key here, there's a really big value. The value is a Python list, as implied by this square bracket. What does this list contain? Well, I know from skimming it earlier that this contains 1 dictionary. And that's why we see another curly brace here. So again, if this gets a little more complicated, keep in mind that a dictionary is just a collection of key value pairs, and Python uses curly braces to indicate as much. It is perfectly reasonable for a dictionary to be inside of another dictionary if the value of some key itself is another dictionary. So this is a common paradigm, and even though it might seem a bit cryptic, it's just something that allows us to associate more keys with more values. Now, most of this information I probably don't care about. For instance, according to Apple, the unique identifier for Weezer is apparently 115,234. That might be useful if I'm making my own database and I want this to be searchable, but for today's purposes, all I care about is the name of the track, otherwise called track name as key. And the first song, and only song, because we limited it to 1, that we got back from iTunes here is the song that you might know by Weezer called Say It Ain't So. So now I have a bit of a clue. If my goal here is to implement a program called itunes.py that doesn't just dump the response from the server, which is admittedly very cryptic, but to print out all of the songs that iTunes has for the band called Weezer, maybe I can iterate over this somehow. So let me backtrack. Here's the key called track name. It is inside of a dictionary that is the value of results here. So how can I go about getting this? Well, let me go ahead and try this. Let me go ahead and shrink my terminal window back down. And let me propose now for one final flourish, we don't just lazily print out the contents of that response, because that's not interesting or pretty for anyone. Let's do this. Let me go ahead and create a new variable, just for the sake of discussion, called O for object. And I'm going to go ahead and call O equals response.json, just to store that JSON response specifically in a variable called O, but I could name it anything I want. And now I'm going to do this. For each result in that object's key called results, go ahead and print out that result's track name. And notice I have used exactly the same capitalization. Track name has a capital N. Results is all lowercase. And let me rewind before we run the actual program. In line 8, we are making an HTTP request using Python to the server, just like you and I as humans type URLs into a browser and hit enter. This is the Python equivalent thereof. I am then on line 10 just grabbing from that variable that contains the server's response the JSON object that I care about, the thing between those curly braces at the very top and the bottom. But because we've poked around and because I read the documentation earlier, I know that that object has a key called results. And that results key, again, is a list. Now, at the moment, that list contains only one song, Say It Ain't So, because I limited my response to one. But even so, my loop will work. It's just going to iterate once. And each time through that loop, it's going to print the current results track name. And so if I want to make this even more interesting, let me do this. Let me change limit now from 1 to, say, 50. And if I want to make this even more interesting, let me change this limit now from 1 to 50, so I'll at least get back 50 track names instead. Let me go ahead now and increase the size of my terminal once more, and go ahead now and run Python of itunes.py, searching again for a band like Weezer. And here we go. And voila, there are 50 songs that iTunes has for Weezer. And if we scroll back up to the top here, we'll see that the very first one there is indeed Say It Ain't So, but now we got Undone, the Sweater Song, Buddy Holly, apparently another rendition of Say It Ain't So, perhaps from another album, another Buddy Holly, Undone, My Name is Jonas, and so forth. Questions now on this program, which integrates Python with a real-world third-party API. Questions here from Akshay.
Yeah, hi. Can we use break instead of system.exit?
Good question, but no. Break, again, is used to break out of things like loops, like we saw earlier. Sys.exit is used to break out of the whole program itself. Use break for loops for now, and use sys.exit to terminate the whole program. Good question.
Thank you.
Other questions now on this program or others. Mohammed?
From where we bring the name of the key results?
From where do we get the name of the key?
Results itself. Yani, can we change the results name?
You cannot. So we could in our program. So the keys that come back in that JSON response, to be clear, come from itunes.apple.com. Some engineer, some team of engineers decided for us what all of those keys would be called, including track name, results, result count, and everything else. You and I can absolutely store those same values in variables, just like I'm doing here with O, just like I'm doing here with result. You can rename those keys anything you want using Python variables, but the JSON response is coming from that third-party server. Other questions on this approach here? Achyut, if I'm saying it right?
Yes, sir. So I have a question related to cowsay package.
Sure.
So like, yes. So, sir, what sort of ASCII graphics is it capable of outputting?
The cowsay package. I would refer you to the URL in the slides earlier, if only because it's more thorough. They have not just cows, but Tyrannosaurus rexes and several other animals as well. I should emphasize that this is not a package I suspect you will use much in the real world. It's really just meant to be representative of the types of packages you can install, but allow me to refer to the documentation for what more is there. But ASCII art is all we had before there were emojis, let alone GIFs and JPEGs and pings, but it's what is immortalized in cowsay. Well, allow me to transition us back now to one final capability of Python, which is that you yourselves have the ability to make your own libraries. Up until now, we've been writing all of our functions in our one file, hello Py and everything since. And now that we've introduced modules in Python, like random and statistics, we can import those that come with Python, but that's other people's code as well. And we've now used pip, this package manager, to install third-party packages as well in the system, and using other people's code still. But to come full circle, what if you yourself find yourself implementing the same kinds of functions again and again? Or you find yourself opening up old programs, copying and pasting code you wrote into new programs because you have the same problem yet again. A good practice would be to somehow bundle up that code you keep reusing and make your own Python module or package. You can keep it local on your own Mac or PC or cloud server, or you can go through the steps of actually bundling it up, making it free and open source, and putting it on something like PyPI for others to use as well. Well, how do you actually go about doing this yourself? Well, let me turn us back to VS Code here, and let me propose that we create a file that contains functions that I feel like I keep using a lot. I keep writing code to say hello, and heck, I'm inevitably going to write code to say goodbye as well. So why don't I just go ahead and implement once and for all a function called hello and another goodbye? And let me avoid the habit of just copying and pasting that into future projects. Let me put it in a separate file with no main function that only exists to package up my code, so to speak. So I'm going to go ahead and run code of sayings.py, where an English saying is an expression like hello or goodbye. And let me just define two relatively simple functions. I'm going to define hello, which is going to take a parameter called name, and it's going to print out using an f string, hello, comma, name in curly braces so that we actually plug in the value of name. I feel like I've done this so many times already. Here now is a reusable function that says hello to that person. Separately, down in the file, I'm going to find another function called goodbye that does pretty much the same thing, takes a name as a parameter, prints out using an f string, goodbye, comma, and then that same person's name. Done. There's no main function now. And to be clear, if I go in my terminal window and run sayings.py, nothing's going to happen. But this time, that's a feature, not a bug, because this is not meant to be a program itself. I am trying to implement my very own package, that is, my very own Python module that other people, maybe me, maybe you, maybe other people on the internet, can import into their own code. I wouldn't therefore want something immediately to happen on the screen when I import this code, or you do. I just want you to have access to those functions. So let me propose now that I open up a new tab called say.py, again from before. And this time, let me not have the cow say anything, but rather let me go ahead and import first sys, so I can take in some command line arguments. And let me go ahead then and import from sayings, import, let's say, just the goodbye function. Now, in this program, I can actually write code that will get executed. Specifically, I'm going to say if the length of sys.argv equals 2, that is to say, if the human types both the name of the file they want to run and the name of themselves thereafter, like David, what do I want to go ahead and do? Well, there's no cow, there's no Tyrannosaurus Rex. There's just a function now called goodbye. And if I pass in sys.argv bracket 1, I should now have access to the goodbye function in the sayings module that lives in a file by convention called sayings.py in the same folder. And so when I run this with Python of say.py, it should indeed just say goodbye. But could I enhance this in any ways? Well, if I wanted access to hello, I could do this. I could import both hello and goodbye, separating them with a comma. At that point, though, if there's only two functions in the file, I might as well just say import sayings, and then go ahead and prefix goodbye with sayings.goodbye. But there, too, it depends on the problem at hand and exactly how many times I want to use this function again and again, or if it might collide with another variable in my file. I think I'm happy with that earliest approach, whereby I import from sayings just the function goodbye, and then on line 6, I call goodbye. And here I'm going to go ahead and say Python say.py, and rather than my name, I'm going to go ahead and say, how about everyone, and enter goodbye. That's it for this lecture on libraries in Python. We'll see you next time for all the more features so you can continue to build your own programs on top of these. Okay. All right. Happy, and actually, can we do one, are we still rolling? Can I fix that? Just going to fix that one ending so we get it right, and then we'll do some casual Q&A, but we're officially a wrap in just a moment. All right, so give me 1 second. All right, if I now make my terminal window bigger, run python of say.py, but this time provide a command line argument rather than my own name, let me go ahead and say, oh, how about world, so that now when I hit enter, we see our final saying today, which is indeed, of course, goodbye world. That's it for our lecture on libraries. From here, we'll continue to build on this with more and more syntax, more and more features, so that you can, too, build projects of all the grander scope still. No, all set. Thanks. All right. Any questions that we can answer here? We are officially a wrap if you need to go home, go to sleep, go to work, or the like. But happy to take some questions here. Yes, Matali, if I'm saying that right?
Hello, David.
Yes.
Yeah, my question is, if every time I don't want to write anything like svs dot, then what I want to write?
Say that again. If you
SYS. At every time, if I use so many methods of SYS, okay?
Oh, yes.
And if I don't want to write every time SYS dot, then what I have to do?
Correct. Let me just pull up a blank file here real quick. So if you're tired, if you have import sys at the top and you have lots of lines like sys.argv or sys.exit and you don't want to keep typing sys, that's fine. You can say instead from sys import argv, comma exit, and now you can literally just say argv down here, bracket 1. You can literally just say exit. You don't need to prefix it anymore. However, you cannot have your own exit function or variable. You can't have your own argv function or variable. You have to decide which is more important. Good question. Other questions from the group? Yeah, let's see. Buwan, if I'm saying that right?
Yeah. Hi, David. I wanted to ask that, can we make mobile apps in Python later?
What later in Python? Sorry?
Mobile apps.
Oh, yeah, probably, but not really. Like Python is not a language people reach for when implementing mobile apps. I suspect there are libraries that make it possible. I'm completely guessing, but it's just not commonly done. Sorry? Oh, can we unmute again?
Yeah, I researched on that, but I tried something here and there, but they were not that good in design.
Yeah, I think for mobile apps, you generally, for Android, want to use Java or Kotlin. For iOS, you want to use Swift or Objective-C. Or you want to build for both platforms at the same time using HTML, JavaScript, and CSS using libraries. You might use Python on the back end for the database or for the servers, but it would be unusual, if even possible, to use Python for the maps themselves.
I had one more question too. Like, can we make our own APIs for like?
Yeah, absolutely.
How can we make them?
A good question. Hard to answer quickly. Carter, can you Google Python REST API and try to link to a library? Short answer, you can. If you're interested in this, I would take CS50's course on web programming, where one of the weeks focuses on making APIs. If, Carter, you wouldn't mind pasting into the chat, CS50W. Too hard to answer in a single question, but I can give you a whole week of a course. Other questions?
Yeah,
Sure. Of course. Let's see. Go over to Mahimani. Sorry, I'm not pronouncing that right.
Hi. Can you hear me?
Yes. How do you say your name?
It's Mamniena. It's a long one, but you can call me M.
M. Okay, good. It's also a very small font on Zoom here.
So here's the thing. When you imported a library you have created, do you have to import all the files you have imported in those library you have created, or you don't call them anymore in your main? Yes.
So if I'm hearing you correctly, if your own library uses other libraries, That's fine.
Yes.
So long as the library imports them, that's fine. You, the
right.
developer, don't need to import everything. It all happens automatically, recursively, so to speak.
Okay. Thank you. Thank
Sure.
you.
Other questions? Mamala, if I'm saying it right?
Hello. So the method that you used with the link, is that the same method that you can use in web scraping?
Oh, short answer, yes. So web scraping, for those unfamiliar, refers to writing code that scrapes data from websites. That is, grabs the data and then does something with it. You can absolutely use the requests library and the get function to get the contents of a website like I've done. It tends to be more painful because websites change and sometimes your code breaks, but there's other libraries that you can use to make your life a little easier. And if you Google something called Beautiful Soup, if Carter, you wouldn't mind Googling that too, this is a very popular library to use with the requests library, Beautiful Soup. And I suspect the name means like, oh, it's a beautiful web page, but it's a soupy mess of HTML tags and the like. Makes it much easier to analyze that. But when you can, using APIs like iTunes, so much better because it's clean data. Good question. Others? Let's see. Aeneas, if I'm saying that right?
Yes, hi. It's not really clear for me what is the difference between a module, a library, and a package.
Sure. So in Python specifically, a module is a library that's implemented in a file. So if you have, we used random.py is a file somewhere on your Mac or PC or the server you're using that contains functions that we're using. A package is code that's in a folder in Python. And the difference is that it can be more structured. You can have folders and subfolders, and you can organize it a little differently, and you can expose only a subset of the functions. With that said, if you read Python's documentation, they say module everywhere, even when they mean package. So honestly, they're effectively synonyms, and it doesn't really matter what you say. And they're all libraries at the end of the day, too. But those are the simplest differences. Module is a file, package is a folder. But that's not always the case. Other questions? Amber?
Hi, can
Hello.
you hear me?
We can, yes.
So this was something that happened with Java, but I have a question with Python libraries. And that is when you're importing a library, it's technically locally onto your IDE, onto your machine. So it's not technically live on the web where someone can mess with the code per se. And then if you let's just say you decide to use that library locally on your machine, it's not going to do funny things.
Well, yes and no. So first of all, when you install a package like I did with pip, you are indeed downloading it from a server, installing it on your own Mac and PC, and then that's it. It shouldn't be making connections to the internet or snooping on you or anything like that. However, at the end of the day, you can do anything with code. And it's possible that a library could be doing what you're worried about there. And one of the biggest risks, too, about using other people's code is you have to trust them. And honestly, who's to say that today my machine is not now hacked because the cowsay package, while pretending to just say moo on the screen, is actually deleting all of my files or stealing all of my passwords. Like there's a huge amount of trust that goes into using other people's code, either commercial or open source. One of the upsides, though, of open source and the fact that you can go look at the source code for cowsay is the presumption is there's enough of us smart people in the world, more by the day, that read code. Odds are someone's going to notice if the person who wrote cowsay is doing something inappropriate. However, it might be too late for you. So at the end of the day, the only advice I really have is to beware. Be careful. Don't use any and all packages. Make sure you're using reputable ones. But even that just decreases the risk. It doesn't eliminate it.
Thank you.
Sure. And I really hope the cowsay package is safe. Otherwise, we created a problem here. Maria?
Hi. Hello, David. Thank you for amazing lecture. Sure. Can we use XC when we check a conditional, did we write a name or not?
Oh, say the first part of the question again.
Can we use XC?
XC. I'm not hearing that word right. Oh, accept?
XC, agree. Like we use it in C++. Int mine, int argc, char argv, and another.
Oh, argc. I'm sorry. Okay, Python does not have argc. Python only has argv, but because Python has a length function, len, you can get the length of argv, which is the same as argc. So the only way to get access to command line arguments in Python is using sys, like we did today. It doesn't happen automatically like it does in C and C++. A good question. I think we have time here for just a couple more questions, if that's OK. Let's go to Abe.
Hi, I was wondering in the iTunes file on line 8, what is the type of response?
Let me go to line 8. Oh, what is the type of response? That is a good question. It's a requests object. Let me check. Python requests get. So when in doubt, you read the documentation, because I don't recall what it is called. So let me see if I can find this real fast for you. This is the documentation that we linked earlier. I'm going to API reference. API, for what it's worth, doesn't have to mean a third-party remote server. Local code, local functions and files can have their own APIs. It's a very generic term, meaning what are the functions? What are the inputs? What are the outputs? Same thing on the iTunes side. So here I am in this function. Let me see if I can find returns. It returns this. So we'll talk about this later in the class. Python does support object-oriented programming, OOP, and there's a class in the requests package called response. So Abe, it literally returns a response object. Let's see. Other questions? Time for maybe 2 more here. Yash, if I'm saying it right?
Yes, sir. I have a couple of questions. Can we create, I have seen on YouTube many programs like creating Jarvis with Python, creating AI with Python. Is it possible to create your personal assistant on Python?
Absolutely. Python is very versatile. I would say, per the other question, the only thing it's really not good at or designed for is mobile apps. But absolutely, for artificial intelligence type applications, it is incredibly popular. You yourself could write the AI functions. However, there's a lot of commercial and free libraries you can use to do that for facial recognition, for optical character recognition, speech synthesis, natural language processing, and the like. There's third-party APIs that you can send audio recordings to, and they'll translate it back for you. Short answer, yes. And by the end of this class, you should have not first-hand experience with that, but enough programming experience to tackle it. Carter, if you could paste the AI class URL. A colleague of ours teaches a class on AI in Python that you might really like. And if we may, maybe time for one more question, and then Andrew, if we could, once we drop off of Zoom, keep the cameras rolling just to record a short snippet, that would be great. And let's see, over to, and please forgive if we don't quite get to everyone here, Abdelaram, if I'm saying it right?
Yeah, hi.
Hello.
Hey, there's some questions that is not related to, but it's not related to the lecture, but it's like, how does one make a programming language? It's just a question. How did Python came to the world?
And what was the first question? How does someone make a programming language?
Yeah.
Yeah, it's a good question. And if this is of academic interest, you can take whole courses on this because all languages were invented by humans. To oversimplify a bit, you, the human, decide what are all of the functions going to be called? What is all the syntax going to be? The curly braces, the parentheses, the equal signs. You come up with what's called a grammar. And a grammar, like in English or any language, is like the fundamental syntax that you have to use to express yourself in that language. Then what you generally do is you write something like an interpreter. So someone years ago wrote a program called Python, and its purpose in life is to read a file, top to bottom, left to right, and convert each of the functions it sees, each of the variables it sees, essentially into the equivalent zeros and ones that the computer understands. And that's a bit of an overstatement. You don't have to worry about the zeros and ones, but essentially you use an existing language to write an interpreter for a new language. And you know what? If people like your language, someone else 10, 20 years from now might use your language to write an interpreter for yet another language. And so we keep layering and layering on top of things. And Python itself, honestly, I would refer you to Wikipedia. If you Google Wikipedia Python, you'll see the history. It came out, I think, in the late 90s. It was the brainchild of one individual who was involved with the community for many years. Now there's a whole group that governs updates to it. The language itself keeps evolving. I know we still have hands up, but we need to get out of the space here on campus. So I hope you won't mind if we officially adjourn here. Thank you all so much. We will see you next week if you can join us for more Python. Have a good weekend.